I'm just
It is,
looking for the
I suppose it is morning in UK.
It's morning in UK, but it's
Okay.
late morning. It's
Good
a
morning,
nice
John.
morning.
I'm Dr. Ashish this side.
Good morning. Nice to meet you, Ashish.
Same.
I do hope you're well. You have lots of people. Would you mind
Yeah,
if
actually,
I just try?
some authors are presenting their paper, so I think within 10 minutes we will start with your talk.
Okay, so I want to share my screen just to make sure it works.
Sure, you can.
Keynote. That's the one. So. Let me just try that again.
Ekansh, please help him. He want to share his screen.
Yes, sir. Sure.
Thank you. I'm online, my love. So if I do this, and then
Do you have any problem in sharing the screen, sir?
I'm just setting it up so that it works the way I want it to. It's not
Okay.
always easy to do. What I'm doing is I'm playing. That's the one there. So if I share that.
Yeah, it is now visible.
Is that good enough to see? Let me scroll back through the slides. You can see the detail on the slide? Fine.
Yes.
That's very good. Can you still see me in the window, by the way? Can you still see my video? Or has that disappeared? Hi, Deepak.
You can just in the view you can just exit the full screen, so you can able to visible you as well as the PPT.
In that case, I won't be able to show my video because I'm not on full screen. I'm just showing
Yes.
individual.
You can just exit the full screen. Exit the full screen. From the right hand side of there's a view button.
Unfortunately, I'm not in full screen when I'm presenting.
Okay.
Sorry, Chair, I'm online.
Yes, sir. You were visible when you were presenting the screen.
So if I share again, this one, then you can still see me.
Yes, sir.
Yes, you are visible.
Oh, that's good. That's really good news. Thank you.
Your slides as well as you both are visible.
Very good. So if I move again, just trying to get it all set up correctly. Sure. If I do that, then that changes. You can still see it. And I'm going to have to change my screen in the middle. So let me bring up another screen. That's the one. That one. And there we go. There we go. Okay, so I'm all ready. So I'll stop sharing my screen.
Sure. Within 5 or 10 minutes, we will invite you and you can start.
Thank you very much. I'll turn the video off until then. I'm going to get a cup of coffee.
Sure.
And pause my microphone. It's it's so good, Deepak. Thank you. Thank you for being there. Really good to meet you.
Okay.
Volunteers are requested to visit the room and kindly make sure that all the authors present in the breakout rooms are tell them and to join the main session. Volunteers, if you are listening, kindly do the same. Good afternoon to Professor John G. Hall from India. I'm
Good afternoon.
on this side. I would like to, in the meantime, let us have some discussions. Means we have actually in the present conference, in the present doctoral symposium, in the morning there was the inauguration session. We means Professor Oscar Castillo and Abul Ella Hasnan, professor from Cairo University, Egypt, and some of the distinguished speakers from the Parent Institute, IET, and from AICT, the Vice Chairman Punia ji, and from IIT Kanpur, which is one of the most reputed institute. Padam Shri awardee Professor Mantri ji has come, and in the conference we have received around 400 research paper in the doctoral symposium in this, and we have only shortlisted 74 research paper for the Springer AISC series, and this is the second version of this doctoral symposium, sir, and the some of the extended papers will be sent to the some reputed journals, means to the SCI and SCOPUS journals. So this is the just a brief outline of the conference. So which I would like I thought to share with you, sir. In the meantime,
I think we can start. Ashish sir,
yes,
can we start?
Yes, we can start.
Okay,
sir.
okay. Muskan.
Yes, sir. Hello, sir. Greetings, everyone. Welcome to the keynote session of Second Doctoral Symposium on Computational Intelligence 2021. Doctoral Symposium on Computational Intelligence is organized with the objective of bringing together innovative scientists, professors, research scholars, students, and industrial experts in the field of computational intelligence to a common forum. The primary objectives of the Doctoral Symposium are to provide a platform for sharing the research ideas on an international level and to meet domain experts to discuss research concepts, methodologies, and career issues. Moving on towards our first talk of DoSCI 2021, it will be my honor to introduce Professor John G. Hall from the Open University, UK. Professor John Hall is a leading research scientist in organizational problem solving. He has extensive experience in designing, leading, and evaluating research programs in many fields, including organizational change, fintech, safety critical systems, and project management, and has a long history of delivering excellent value to business. Professor John's research has influenced industrial practice both directly and through contributions to international standards. In terms of his personal research, he began his scientific career as a logician in Newcastle and York universities, conducting research on engineering alongside Professor John McDermott, one of the leading proponents of the use of mathematics in engineering. After researching logic for many years, he began to apply the techniques to software engineering and then more broadly across engineering, finding deep links between ostensibly different areas. His most recent research explores problem-solving structures that bridges the chasm between agile and plan-driven approaches to solving complex problems, holding out the hope that wicked problems, previously unsolvable, will soon be effectively understood and treatable. He is the editor-in-chief of Wiley's Expert Systems, the Journal of Knowledge Engineering. I welcome Professor John G. Hall, and he will deliver his talk on topic, Organizational Computational Intelligence.
Thank you ever so much, Muskan, for that wonderful introduction.
Thank you, Flo.
I'm quite embarrassed by it. Okay, so I need to share my screen with you, which means I need to find the window that, there it is. So let me share that with you. I'm hoping you can all see that.
Yes, I can see that.
That's very good. So as Muskan said, my name is John Hall. I'm not actually a professor, I'm just a doctor. I'm here in the United Kingdom, where the time is about 12 minutes past 11. So for me, it's good morning. For you, it's good afternoon. So good afternoon, India. It's so nice to be here. First of all, let me thank the program committee of this symposium for the opportunity to tell you something about my research and how it relates to computational intelligence. I should say that I'm not an active computational intelligence researcher, or not in the way that you would immediately see it, but I do see the massive possibilities for its sophisticated use in organizations in the way they change, which is one of my deepest research interests. So you're going to hear something about organizational computational intelligence today. A subtitle for this talk might be something like, well, organizations are very complex and they find change extremely difficult. But computational intelligence might be able to help us manage change so that we can move into the future more quickly. But I want to give you some background first. I'm from the Open University in the United Kingdom, which is just up the road from London, in Milton Keynes, beautiful city. The campus of the Open University is one of the most beautiful in the UK. This picture is taken of the Jenny Lee 2 building where I work, or I used to work until COVID struck. It is a beautiful campus. If you ever get a chance to visit us, I would love to show you around campus. The OU celebrated a half century last year. It's 50 years old, 51 years old now. It's one of Europe's largest universities with almost 250,000 students and growing. Now, I realize that's nowhere near as large as your Indira Gandhi National Open University in Delhi, another open university with its 4 million plus enrollments. But the Open University is a large university for Europe. In its 50 years, the OU has created over 2 million graduates. The OU is the largest provider of law graduates in the UK and one of the largest providers of MBAs in the world. I know I have an Open University MBA. And we also have around 1,000 PhD students. Our students are some of the most motivated out there. 87.5% are in work, and many own their own business, and they're studying so that their business can grow. This is the journal, Expert Systems, that I edit. It's now in its 37th year. I've been with the journal for 11 years. It's now in its 37th year. Expert Systems is one of the most innovative journals in academic publishing in terms both of content and of the processes behind publishing. We welcome papers in any aspect of knowledge engineering, including computational intelligence. You'll find a lot of free content on the website, which you can get by scanning the QR code in many areas that you'll recognize. In fact, fuzzy logic, NLP, neural networks, evolutionary computing are some of our most popular topics. I'd like to extend a very warm welcome to you to submit. And also, we're currently recruiting reviewers and editorial board members that can bring deep understanding of the areas of computational intelligence expertise to the journal. So please do get in contact with me if you want to join my team. Contact details are at the end of the presentation. Also, I'm Director of Education for Synexus Solutions. And this is my great boss, Sheldon Stout. He's CEO of the company. Synexus harnesses technology to empower, engage, and connect communities for a sustainable future. Synexus exceeds the latest environmental, social, and corporate governance criteria and standards for sustainable and socially responsible investing. I'd also like to introduce you to two other people on the call this morning. One is Daryl Bowden, and the other is Lucia Rapinotti, who've kindly joined us today. Daryl is founder and CEO of Glia Ecosystems, and he's a businessman working at the leading edge of computational intelligence. His ideas for how business use data are revolutionary. And I think if you do ask a question today, and I hope you do ask questions today, Daryl's the guy you're trying to impress. Lucia, who's sitting just over there, is my colleague at the Open University, and it's our research together that I'm talking about today. I'm Lucia's husband, by the way, which is why we're sitting together in the same room. Okay, I should say that this isn't a picture either of Daryl or Lucia, by the way. So this isn't Daryl or Lucia, by the way. But we are going to cover an awful lot of ground this afternoon, including one sci-fi singularity and what organizations are. The number 164,769 will be important as motivation, as will 70%, and 304 will also crop up in the context of computational intelligence. Later, we'll be thinking about how science works and how it could apply through computational intelligence to organizations. Finally, I'm going to be setting a challenge to any of you computational intelligentsia out there whose ambition is to work with business. So why this picture? Well, the popular IT press in the UK are very concerned about the singularity. Sounds like science fiction, something out of Star Trek movie. Entering the singularity now, Captain, phases on stun. Well, it's not that, but it is science fiction. But it's not that sort of singularity. There are no wormholes inside. No, it's much more like the Matrix plot, which I hope you know, or the dystopian future world of the Terminator, again, which I hope you know, where super intelligent machines created by humans have taken or take over the world. As science fiction, it's a relatively old concept, first written about by Vernor Vinge in his 1981 classic seminal work of cyberpunk fiction novella, True Names. Spoiler alert. The plot behind True Names is that we have passed the point in the future when in silico intelligence has higher cognitive power than in corpo intelligence. Simply, robots have become more intelligent than humans. From that point on, it's all downhill for us. We quickly cease to be the dominant force of life, and well, a while later, a digital Sir David Attenborough, who I hope you know who he is, prompts adoring reviews from a digital press for its description of the human, that is, an interesting but lower form of life. Now, unless there's a mad genius amongst you in the audience today, and in this audience there will be geniuses that will perhaps turn mad during their PhD, unless there's a mad genius out there able to thrust a computational intelligence able to dominate the world fully formed and kicking into it, such a takeover is either going to be A, an emergent property, or B, criminally irresponsible knowledge engineering. Isaac Asimov, the greatest sci-fi writer and author of I, Robot, had it right in his novel-length examination of the 3 laws of robotics. I hope everyone knows Asimov's 3 laws of robotics. You may have seen them through Will Smith's vehicle, I, Robot. Great film. Anyway, paraphrasing Asimov, scratching a superintelligence with the goal of protecting humans, and you'll find a domineering parent who takes all the dangerous toys away. Asimov introduced his 3 laws in his 1950s novel, Run Around, which is part of the I, Robot collection, published by Doubleday. And the film, I, Robot, with Will Smith, is good. but nowhere near as good as the book. Back to the Terminator. Anywho, long before any hard controlling post-singular computational intelligence, there is this responsible computational intelligence community. Soft, beneficent, singular intelligences that have a major role in the world. And I know this because I've looked at some of the papers published in this conference, where you describe the forward steps you have made to, for instance, assist health professionals in their duties, including in pregnancy, an incredible and important computational intelligence application. So well done for that. And to improve engineering, to make society a better place to live, and, well, simply to make better life for many people. These roles extend before your PhD. Now, I can't ask you to raise a virtual hand if you think you'll end up working outside of academia, because I just can't see everybody. There isn't a room to take a vote in. So I've tried to answer that question myself by looking at the papers. So Dr. Gupta, the organizer of this excellent event, and someone to whom you should be eternally grateful for the opportunity to publish so early in your career, shared with me the titles and some abstracts of your 68 accepted papers, so I could find out. A very shallow analysis reveals that very few of you are actually focused specifically on a technology, only 10 or 13%, or 20% if you count natural language processing as a technology. Only 6% are focused on nature. Don't get me wrong, these are excellent areas for studies in computational intelligence. In fact, nature, given computational intelligence's background, is perhaps the perfect place to study it. However, by far the greatest proportion of you want to deliver to society through health at 21% and business at 52%. Each of which is a massively complex and volatile area with millions of stakeholders, billions of stakeholders, in fact, each with very complex and volatile needs. And for this reason, for this presentation, I'll group health and business together. What about business? Now, if you were to attend an MBA, a Master's in Business Administration, at your or any other good university, you'd hear all about the great organizational model for strategies, operations and marketing, the mission and the vision, resource management, quality control and improvement, human relations, stretch and leverage, and many other brilliant theoretical models that have allowed us to get to where we are in our current understanding of organizations. I have an MBA and I studied hard during it in the year 2000. And learned all of these models and more. But when I got them to the real world, when I tried to apply them to the organizations that I worked with early in my academic career, I saw the difficulties that they have for one critical area in the organization. What's that critical area? Well, the truth is, in practice, that the traditional models of business don't work very well when the organization, or a business, a charity, or any other organization needs to change. In fact, the models of organizations that we have are so poor that 70%, I repeat that, 70% of all organizational change projects fail. That's reported by McKinsey & Company. Currently, organizations are just throwing money at change and wasting most of it. But it's only because all organizations fail at this 70% rate that we don't see the problem. It's the norm. And even if it is an economic car crash, organizations say, move on, nothing to see here, folks. Happens every day. But what if your favorite cricket team were to lose 70% of the matches? You'd really want them to change, right? And what if you had a way of bringing that failure rate down to 60% or 50%? What if you're able to help them win 70% or more of their matches? You'd be very popular. They'd be more competitive, and they'd soon be moving up the league. This is my favorite cricketer, by the way. Although I support England in cricket, Bishan Bedi is my favorite cricketer. beautiful guy, one of my all-time favorites, absolutely superb bowler, took 71 wickets in limited overs matches. Sorry, back to 70%. It's the same with business. Reducing failure through the use of great models, which give a deep understanding of change, translates to real competitive advantage in the real world. But there are many other benefits to a deep understanding of change. For instance, it means that an organization can use new technologies, like the one you and your supervisor are working on, much more quickly. They can be more agile and be quicker to enter new markets. In short, understanding change deeply means turbocharging a business. Is there a model that helps change? Is there a model that you could learn that would help you take the computational intelligence skills set that you have or are developing and use it to help organizations change? Well, Lucia and I think so. And it's something that we've been working on for the past 15 years. We've studied possibly hundreds of organizations and how they change, and have come up with a new model for change in organizations. And I'm going to reveal it to you now. Are you ready? Well, here it is. Our model of an organization is, ta-da! Oh, it's not what you're expecting. That's okay. But honestly, it's an extremely useful model. Let me tell you why. You've got to look deeper at this model to really understand it. So look deeper and deeper. I promise, I'm not trying to hypnotize you. Okay, it's a ball of wool. But the first thing you notice is that it's made up of hundreds of different colored strands. To Lucia and me, each of those strands represents a solution. So we can write an organization is a set of solutions. Of course, for this to make sense, I need to tell you what a solution is. Well, each solution is a collection of phenomena. The important thing about phenomena is that they generate observable events or data. So when a solution does something, it generates observable events which can be recorded as data. That's going to be important. In addition, the causal relations between phenomena define the structure of the solution, and that in turn defines its behavior, meaning that we can define a structure, sigma, and a behavior, beta, of a solution as well. Of course, there's nothing special about the data that phenomena generate. Every item of data ever produced is generated by some phenomena. What's special about our model is that we make phenomena the heart of the organization. So even if an organization looks like a tangled ball of wool to you, it is actually an engine that runs on phenomena occurrences. What else can we say about our ball of wool model? Well, looking again, we see that it is tangled. Each strand is tangled with many others. For Lucia and I, the way the strands tangle is through the phenomena they share. So we say two solutions tangle if, and we write the tangling as theta of Si and Ji, if and only if two solutions tangle, if and only if they share phenomena. When two solutions tangle, they constrain each other. The behavior on their tangle, on the phenomena they share, must be equal. This, of course, means that the data generated by each solution on their tangles has to be shared too, although, of course, two observers might observe it differently. But that's the story for another keynote. It also means that the behavior of the two or more solutions together is the join of their behaviors. That is, whenever they interact, they must agree. That's important. So I'll say it again. Whenever solutions interact, they must agree. So, the ball of wool model allows us precisely to define the behavior of an organization in terms of its solutions and in terms of their phenomena and how they share. Now, I've said that solutions have both structure and behavior, and it's true. And that there are collections of phenomena, which is also true. But where do solutions come from? And what do they look like? Well, those were two very good questions. I'm going to answer them in order. First, where do solutions come from? I don't think it's going to surprise you to know that a solution solves a problem. Aha, you're thinking. Now he needs to tell me what a problem is. Yes, ever eager to please, Lucia and I think that a problem looks like this. So, our solution, which in this slide is CIP, solves a problem when it meets a need, N, in an organization, O, to the satisfaction of some stakeholder, G. Now, there's a lot of complexity in this equation, and I'm not going to go into much of it. In particular, although G is a critical part of a problem, that's a story for another keynote. Also, realistically, the organization's context, which here is represented as O, will also include people like customers, other organizations in the organization's supply chain, regulators, legislators, auditors, and so on. But that's not something I want to get into either today. It would make it too complex. Here I've called the solution CIP, standing for Computational Intelligence Product, which may be the product of your PhD research. In fact, it could be that you've been employed as an organizational problem solver to write a fuzzy decision support system, or a neural net to help identify the most profitable customers that a business has, or a genetic algorithm to optimize a workflow. And you've delivered. So you've got to implement your solution within the organization so that the organization can benefit from its use, i.e., so that the organization can change. And this is what change looks like. Implementing your shiny new solution in the old organization leads to a new organization. O prime. Of course, it's not a new organization. It's a changed organization. But as I've said, change is incredibly hard, and 70% of change projects fail. This equation makes it look quite easy. So where is the difficulty? Well, if we come back to your CIP solution, you'll have realized that in solving the organization's problem, you've also learned something about the organization. So you can tell the CEO that to do its best job, your CIP solution will need new data gathered from across the organization, which means currently existing solutions will need instrumenting, and so changing. Important point. You'll also be able to tell the CEO that your CIP solution will need new hardware to run on, and that it will need a whole new team to implement its revolutionary findings across the organization. And finally, that your CIP can replace the current way of doing things, which can thus be decommissioned. In short, as well as delivering your CIP, you know precisely how the organization needs to change to get the most value from your solution. Now, getting from O to O prime, what you've just done there, is what Lucia and I call the change problem. Every new solution ever implemented within an organization has an accompanying change problem that makes it work for the organization. So what can our ball of wool model tell us about change problems? Well, with the CIP example above, we can see that if an organization is a collection of solutions, changing the organization means changing the solutions. That sounds easy, but remember that the solutions tangle together And so changing one is likely to affect those that tangle with it. To change an organization, when we introduce a new solution, we must be careful to ensure that nothing that we want to preserve in the organization breaks. Even though it is extraordinarily difficult to solve change problems if all you know is the solutions, using Lucera and my model, we know more, because we know those solutions came from problems, and that those problems have needs which constrain phenomena across the solutions. And if you know the needs the current solutions satisfy, then you know how those solutions tangle. And by tracing back through the tangle, you can work out which current solutions will be affected by your solution when it is introduced and how. And that's extremely valuable information for solving the change problem, as you now know where to look to change. Unfortunately, in the real world, what usually happens is that an organization is so excited about a shiny new solution it forgets all about the problem that solution solved. All the organizational knowledge that was created to get to the new solution is forgotten. It's lost. It's not available. So if only we could reconstruct those problems from the current organizational state. If only we could look at what we can observe of the organization and its solutions and work out the needs that produced those current solutions. If only we could find patterns in the data that we observe that tell us something about how the current solutions overlap. If only we could find patterns in the data. Wait a minute, isn't that what computational intelligence can do? Lucera, my belief is that solving the change problem is something that computational intelligence can help address. It may not, of course, get us 100% of the way, but even a few percent would help reduce that 70% failure rate. Now, at the current state of the art in organizations, this is a massively complex problem, almost needing a research program to be solved. Is there a simpler problem that we can start with? Well, we actually think that there is. Has anyone not heard of AlphaGo? Again, I can't see what you're saying. I do hope you've heard of AlphaGo. The aim of the AlphaGo project was to play the perfect game of Go, based on deep learning from human and computer games. The team behind it were called DeepMind, who are now part of Google. In October 2015, in a match against Go professional Fan Hui, AlphaGo reached human levels of Go skills by becoming the first computer Go program to beat a human professional without a handicap on a full-sized 19x19 board. That was an absolutely massive achievement. However, AlphaGo was comprehensively beaten by its successor, AlphaGo Zero, which learned to play Go after 21 days of playing itself. There was no training data, human or otherwise, supplied to AlphaGo Zero. It just taught itself. It didn't even have the rules of Go programmed into it. On the 5th of December 2007, the DeepMind team released a preprint introducing AlphaZero, which within 24 hours of training achieved a superhuman level of play. And in 2019, AlphaZero became MuZero, a unified system that played excellent chess, better ever than any human, shogi, and Go, better ever than any human, as well as some games in the Atari learning environment, without being pre-programmed with their rules. The story of AlphaGo is as terrific as it is important for computational intelligence. I can almost believe the stuff of sci-fi nightmares, like the Terminator and the Matrix, are just around the corner. They're not, of course, but for a moment there, they could have been. If you don't know about AlphaGo, there's a superb whole film AlphaGo on YouTube, which should be available in India. If you scan that QR code, you'll be able to find it. But back to Earth. AlphaGo and its descendants are amazing. But did you know that the first human beating computational intelligence was built all the way back in 1960? That's even before I was born, and I'm quite old. Donald Michie, a Bletchley Park cryptanalyst. The significance of Bletchley Park is that it's just up the road from Milton Keynes, where the Open University is. So Donald Michie, a Bletchley Park cryptanalyst that had helped break the German Tunny Code in World War II, might be called the inventor of machine learning, artificial intelligence, computational intelligence, all of those things. Because in 1960, even before computers were a big thing, Donald came up with the idea for a tic-tac-toe playing computational intelligence system called MENIS. MENIS stands for Machine Educable Noughts and Crosses Engine. Noughts and crosses being the English name for tic-tac-toe. I don't know which one is current in India. Michie went to school in England, hence he called it noughts and crosses. What was the technology behind MENIS? Well, the original MENIS was built from matchboxes. You can see some of the 304 matchboxes needed in this picture. Each matchbox represents a game position and contains a number of matches which indicates which was the current best move to make from that position. The number of matches were updated depending on whether MENIS won or not. Now, I need to stop sharing my slides and bring up another window for just a moment. So now you're seeing a different window. Because I hope you can see a different window. Could Muskan give me a thumbs up if she can see a different window?
Yes, so we can see.
That's lovely. Thank you, Muskan. But now we're in 2021 and we can do much better than matchboxes. This web page is a JavaScript implementation of MENIS, currently playing a random opponent. I've been running this for some time now. You can see there have been around 90,000 games. And in that time, MENIS has become quite good at tic-tac-toe. Essentially, it doesn't lose any more against a random opponent, or it loses less than 1% of the time. And even against a perfect opponent, which I can play now, MENIS always, pretty much always gets a draw. Of course, MENIS knows nothing of the rules of tic-tac-toe because it doesn't need to. But it does understand, in some sense, tic-tac-toe and plays a very good game. Let me repeat that. MENIS doesn't know the rules, but it plays a good game. Now, for us, that's quite interesting, isn't it? What if we could reverse engineer the rules of tic-tac-toe from MENIS's understanding of the game? So let me change back to my slides. So here we go. Hopefully, Muskan, you can see a change back to slides.
Yes, so we can see.
Lovely, thank you. So, well, I mentioned at the beginning that I'm going to set you a problem, a research challenge, and I'm going to call that the tic-tac-toe research challenge. The research challenge is to reverse engineer the rules of tic-tac-toe from the data available from playing the game. Essentially, looking back at the MENIS, the web page that I've just showed you, you would get the right-hand side of the screen, and you need to produce the rules of tic-tac-toe, which I show on this side. I'll say that again. The challenge is, given the data, to come up with the rules. If you do take up that challenge, to solve it, you're going to have to use patterns in the data to construct hypotheses, which can then be tested against the data. I hope that sounds familiar to you, because that's the mechanism of science. Well, nice challenge. I hope you agree it's a nice challenge. I'm going to spend some time thinking about it, but obviously it has to have some relevance to an organization. So, what's the relevance to an organization? The tic-tac-toe challenge is to reverse engineer the rules of the game from what can be observed of the game. What if, like automatically reverse engineering the rules of tic-tac-toe from game data, we could automatically reverse engineer information from the problems that an organization faced from the data observed of them? That's like tic-tac-toe challenge, but 1,000,000 times more complex. But developing techniques from the tic-tac-toe challenge would be a start. And as we saw earlier, it's the solutions to organizational problems that are observable, not the problem themselves. However, we've also seen that change in organizations is easier if we can find the problem that generated the solutions. Getting from the solutions to the problems is a job for computational intelligence. I see I've got about 5 minutes left, so I'm going to speed up a little. Reverse engineering problems from data is something Lucia and I call problem science. The tic-tac-toe challenge and its generalizations is really therefore asking whether CI, computational intelligence, can do problem science. Problem science just applies the general scientific method to build models of problems solved from their solutions. As you know, the scientific method is basically observe, generate questions to answer, formulate hypotheses to test, reject and refine, develop general theories, and iterate. This is what this slide shows how that is specialized to problem science. Given that we've defined problem science, who would benefit from it? Well, in the long term, everyone will benefit from it as organizations become able to change without failing so much. That's a massive benefit to all of society. In the short term, the people that will benefit the most are those that can use its tools to help organizations to change better. And that could be you, as you take problem science, perhaps, and computational intelligence expertise and your PhD into all those organizations that need to change. That brings us back to your research. So finally, just a few words about your PhD. After your PhD, you will become the next generation of computational intelligentsia. Some will stay in academia to be the organizers of conferences, workshops, doctoral or otherwise. You do some massive research, you make some life-changing interventions, and you will deliver those to the many communities that are thirsty for you and your supervisor's research work. This is the path I chose, and I know from experience how very rewarding it is. That's the role of an academic. Others of you will be awarded your PhD and set off on a journey into the real world. In the real world, there will be fewer situations in which your PhD is useful. Your area of expertise, for instance, will be the philosophical malady rather than the health malady. So you will answer the call, is there a doctor in the business, when someone cannot properly conceptualize that most complex of business problems. And you will do that with the mindset of a scientist, critical and curious, exploring and explaining, looking for the trend and patterns, working with the data and creating computationally intelligent tools that you and your colleagues in the organization will be able to use. You will educate in expertise and learn domain knowledge and become wise in the way of business to the extent that many of you will actually build your own business. Some of you may even go on to run your own government department. To succeed will be a massive challenge for you, taking a long life of hard work, not least because of very few people you will try to help will have the foggiest idea of understanding what computational intelligence is or what it can do for them. Having said all that, in today's world, there is no organization that does not need your skill set and that will not benefit from your insights. And they will pay for the privilege. And that's where this number 164,769 comes in, because that's the average US salary for a computational intelligence engineer in 2021. One final thought before I end. Your PhD will be the most difficult thing that you will ever do, but once it's over, there's a whole world of knowledge and skills, both hard and soft, that you will need to learn to succeed. I know that some of you will already have some of them, but I also know that not one of you will have all of them. If you listen extra hard, you'll find that your supervisor will be able to give you some of the skills that you need. They may have worked with business after all and have learned those skills the difficult way by being exposed to situations in which they've needed them. So it's always good to listen to everything your supervisor says, because there's a reason why they're a supervisor. For me, as well as research and computational intelligence knowledge, I think the most important thing to understand to be successful working with organizations and business is to have a deep understanding of how they change. For me, as well as research and computational intelligence engineering skills, I think the most important skill you will need to be successful is to be useful in that change process. And that's the skills I have outlined today. With these skills, you'll do good for any organization you join. Thank you for your attention. That's my email address. If you click the QR code, it'll write an email to me. Please do contact me. If you have any questions, I don't know, Muskan, if we have time for questions, but if you have any questions, I'll take them now.
So there are no questions, but please leave your email ID. You can type the email ID in the chat box.
Okay.
And can I ask something?
Muskan?
Yes, of course.
Yes, I need to ask one question.
Yes. Yes, sure.
Hello, sir. So what is the difference between that computational intelligence and computing machinery and intelligence? Is there any difference?
I've tried to do some research in this, looking at various sources, looking at reports, looking at research papers. People do want to distinguish computational intelligence from artificial intelligence and from machine learning. And I think that's what your question is asking.
Yeah.
Computational intelligence, as I understand it, and I'm not part of the computational intelligence community, computational intelligence is looking at natural ways of solving problems. So the mechanisms that nature uses, that humans use to solve problems. So there's a lot of emphasis on swarm algorithms, on those sorts of things, on looking at the brain, looking at the way animals solve problems, and using that to motivate computational intelligence. The alternative to that is to look at binary, to look at digital ways of reproducing intelligence. Random forests, decision trees, those sorts of binary, look this way or look that way things. So as far as I've been able to see from the literature, the difference is where computational intelligence looks is into nature for its inspiration for intelligence. I hope that partially answers your problem, but as I say, I'm not an expert. Anything else?
I'm a bachelor student, so I don't understand computational intelligence that much. But I just want to know that you show the tic-tac-toe game and AlphaGo, so that uses reinforcement learning.
I didn't catch. Sorry, your voice cut out for a moment, Muskan. Could you repeat the question?
So I was saying that the tic-tac-toe and
yes.
The games that you were showing, like AlphaGo. So
yes.
that uses reinforcement learning.
AlphaGo definitely uses reinforcement learning. The matchboxes are a form of reinforcement learning because what they do is you put more matches in the matchbox to reinforce the fact that you won using that move. So it is reinforcement learning.
Okay, thank you.
Okay.
Sir,
if there's no other questions,
I have one query. Although this query is a very general query, maybe from the audience side, as you are representing expert system also, and
Yes.
so we all are blessed that we have heard you live. And so just if you can tell something about the audience just in 1 or 2 minutes, that what should be the perspective before writing a paper, and so that we can target the journal like expert system, because everyone is means joining on these platforms for because you are here, and it happens once in a while that we hear you. So if you can just tell us that what could be the approach in very brief, you can tell us that while writing.
Yes, of course. Yes, of course. So Expert Systems is a wonderful journal. I love being editor-in-chief of Expert Systems because of the really, really diverse areas that we cover. A paper that comes into Expert Systems, and we have almost 1,000 papers submitted a year. So there are many, many areas in which we cover. 1,000 papers a year is a lot of papers to consider. Clearly, papers need to be in scope. That's the first thing to do. So go to the Expert Systems website and have a look at the scope. The scope covers many things in artificial intelligence, machine learning, computational intelligence, and is in the general area. Anything to do with knowledge engineering is very welcome. There are other journals which cover applications. So if your paper is just an application of an expert system technology, then it will probably not be welcome in expert systems. What we need, however, if you accompany that application of your expert systems technology with an evaluation against the literature, with an evaluation of the state of the art, then it turns from being not welcome at all to being extremely welcome. What we're doing in expert systems is trying to accentuate the science part of expert systems, which means that we need evaluation. We need to know what contribution to knowledge your paper is making. What else can I say? There are some structural things which should be easy for any experienced researcher to think about. We need a well-structured abstract. The first section should be an introduction to the topic. The end of the first section should have how the paper is structured. Second section should be a literature review, and then you get into the novelty of your proposal, and then an evaluation of your proposal, and then the conclusions and any future work that you wish to do. But let me just summarize that in a few words. Has to be expert systems, either a development of an expert systems technology or an application with an evaluation of that. And that's, we will consider any paper from any of your colleagues. I hope that answers your question.
Thank you so much, sir, for the wonderful answer and taking us again to our basics, which is very necessary for all of us to understand the basics. And thank you very much, sir.
So we have a question.
Oh, yes.
So somebody is asking, neural networks is a subset of artificial intelligence, and it is also a part of computational intelligence. Then how is AI and computational intelligence related?
That's a really good question. So first observation was neural networks are part of artificial intelligence and also part of computational intelligence. I agree with that statement, and I agree with that statement because from my reading of the literature, artificial neural networks look to a natural mechanism, i.e. the brain, to do their magic. Computational intelligence takes its inspiration from natural mechanisms. And because the brain is a natural mechanism, artificial neural networks come under computational intelligence. They're also part of artificial intelligence as well, clearly, because computational intelligence would appear, from my reading, to be part of artificial intelligence. So what's the difference between artificial intelligence and computational intelligence? Well, again, from my reading, I see some of the more digital some of the digitally based computational techniques, some of the digitally based expert systems techniques, things like random forests, like decision trees, which are very digital, which are very structured, which are easy for computers to implement, are part of artificial intelligence, but not part of computational intelligence. So essentially, the difference is that computational intelligence looks to nature for its inspiration, whereas artificial intelligence takes its inspiration from anywhere it can get it. I hope that answers the question.
Thank you, sir.
Thank you so much, Dr. Hall. It is a pleasure to have you in this symposium, and thank you for giving your valuable time for this symposium. It is early morning at your end, so
yes.
We are happy that you are here and accepting our invitation to be the keynote speaker at this symposium.
Aninda
Thank
Bose
you so much.
Here with us right now. I welcome Aninda Bose sir also. If he's hearing us, Aninda Bose, I think you must have heard these from Springer Nature. So welcome Aninda Bose sir. Thank you.
Ekansh, I request you to make Aninda sir co-host.
Thank you ever so much for the honor of being invited to your symposium. It's been a real pleasure, and I hope it goes very well.
Thank you.
I'll drop off now. Thank you.
Thank you, sir.
Thank you.
The next distinguished to honor us with his presence is Professor Pierluigi Ciano from University of Salerno, Italy. Professor Pierluigi Ciano received the MSc degree in Electronic Engineering and the PhD degree in Information and Electrical Engineering from the University of Salerno, Italy in 2001 and 2006 respectively. He is a professor and scientific director of the Smart Grids and Smart Cities Laboratory with the Department of Management and Innovation Systems. His research activities are centered on demand response, on energy management, on the integration of distributed energy resources in smart grids, on electricity markets, and on planning and management of power systems. In these research fields, he has co-authored more than 550 articles, including more than 300 international journal papers that received in SCOPUS more than 1,100 citations, with an H index equal to 49. In 2019 and 2020, he received the award as highly cited researcher by ISI Web of Science Group. He has been the chair of the IES TC on smart grids. He is the editor for the Power and Energy Society section of IEEE Access, IEEE Transactions on Power Systems, IEEE Transactions on Industrial Informatics, and Open Journal of the IEEE IES, IET Smart Grid, and IET Renewable Power Generation. I am pleased to welcome Professor Pierluigi Ciano, and today he will be sharing with us his expert opinion on optimization of the operation of residential photovoltaic battery systems in smart grids.
Thank you very much. Good evening. I am very delighted to present this keynote at the second doctoral symposium on computational intelligence. I share my screen. Can you see it?
Yes, sir, it's visible.
Okay, thank you very much. In this, I am very grateful to the organizers for this invitation, and today I'm going to present this keynote that is titled "Optimization of the Operation of Residential Photovoltaic Battery Systems in Smart Grids." In this presentation, after briefly introducing the procurement of flexibility resources in the ancillary services market, I will talk about an architecture for the large-scale aggregation of prosumers that we designed and developed at the University of Salerno in the context of an Italian pilot project. The architecture has been designed to allow an aggregator to participate in the ancillary services market for providing flexibility, solving both the day-ahead and real-time optimizations. Then I will describe a distributed and innovative distributed parallelized linear programming based optimization that is scalable and privacy preserving, allowing to deal with hundreds of thousands of prosumers without disclosing their information. I will then present some results based on a real Italian pilot project. Finally, I will present some findings and conclusions. As known, future electricity distribution grids will host a considerable share of distributed and renewable energy sources. The electric power system is undergoing a rapid transition toward the decarbonization and the decentralization. Residential and commercial customers that once were simply consumers of electricity are now deploying distributed energy resources, becoming producers themselves in a new decentralized power system, as shown here in this figure. The flexibility offered by these new resources and technologies can reduce the electricity and infrastructure cost while enabling the power sector to meet the decarbonization targets. Modern power systems are evolving from a centralized paradigm according to which electrical energy was mainly generated by large power plants at the transmission level to a new decentralized layered decomposition optimization model like it is shown in this figure, where distributed generation, often based on renewable energy sources, represents a relevant portion of the produced electrical energy. In this new model, the provision of ancillary services to the transmission system operator should take into account the flexibility that can be furnished by these new distributed renewable sources, such as dispersed and small generators, also based on renewable energy, and frequently endowed with small batteries. In particular, distributed battery energy storage systems, also of small scale, that were in the past mainly used to decrease the uncertainty due to renewable energy sources and to increase the energy self-consumption for the user, can be nowadays also managed to provide energy flexibility to the transmission system operator. Battery energy storage systems can be directly managed by the system operator or controlled by an aggregator that can offer energy flexibility in the ancillary services market. Considering this new model of modern power systems and in order to exploit the potential and energy, the potential of energy flexibility offered by new resources, the energy, European regulatory framework has opened the ancillary service market to distributed energy resources, including energy storage and demand response providers. Among distributed energy resources, battery energy storage systems have gained recently more attention from many scholars, evaluating their involvement in the ancillary services market due to their high ramp rate and fast response. The proposed methods consider both the planning and the real-time sessions to respectively define the unit commitment and the activation of flexibility resources according to the Italian ancillary services market. Considering a pay-as-bit mechanism and a settlement period of 15 minutes, an aggregator, after carrying out a day-ahead optimization based on day-ahead forecast of photovoltaic production and electrical load, can offer services of flexibility in the up or down mode during the planning session, considering its baseline as a reference. If these offers are accepted by the system operator, then it can ask the aggregator to deliver the flexibility provision during the real-time session. If the energy is not delivered, an imbalance cost is applied to the aggregator, so it should carry out a real-time optimization based on short-term forecast in order to not pay the imbalance cost. It's worth noting that in the last years, the Italian regulatory authority implemented a new regulation that allowed aggregated distributed energy resources such as residential users, electrical vehicles, and so on, to participate in the market for ancillary for the ancillary service. According to this new regulation, an aggregate can be composed of different types of resources without any limit to the rated power of the single resource, but the aggregate must have an overall minimum regulating power of 1 megawatt. On this basis, and considering these requirements, in the last year we have developed, in collaboration with an Italian company, an Internet of Things based architecture for demand response, in which each residential unit is connected to a home gateway and is controlled by an energy management system that has been implemented on a Raspberry Pi 3 microcontroller. It is in communication with the aggregator by means of an interconnection layer consisting of a cloud-based server, a manager gateway, and a database. In particular, a centralized database registers the electrical energy consumption of all the electrical loads and the generation of the photovoltaic systems, while optimization and management tools are employed by the aggregator to assist are employed to assist the aggregator to carry out third-party services for energy saving and smart meter, for example. The user can connect to the energy management system by using a web app, and there are some smart devices such as smart thermostat, smart meter, smart plugs, smart appliances, the photovoltaic system that can be connected by Z-Wave or Wi-Fi communication to the energy management system. These devices have been selected by among commercial devices, and you can see here some commercial devices that we selected to include in the architecture, while the energy management system is shown here in the center of this slide. And also other devices can be connected to by developing the required software. And we implemented some rules using Blockly Visual Programming Editor, as shown here, for example, for the control of a boiler using a smart thermostat and a smart switch that are connected by means of Z-Wave communication to the energy management system. Another example of application we developed is shown here, in particular for the control of a smart lamp in connection with a light sensor, both connected by means of Z-Wave communication to the energy management system. Also, we implemented some rules for a security system and a siren, and a scheme for with the two Z-Wave connected smart meters like these ones, and a smart plug in order to exploit to maximize the renewable energy exploitation from the photovoltaic system. Then this Internet of Things architecture has been further developed to become a transactive management infrastructure for a virtual power plant aggregator. More details can be found in this paper if you are interested. The motivation behind this developed architecture is are that usually in a local energy market managed by virtual power plant aggregator, prosumers and consumers can trade energy and flexibility within the energy community in a peer-to-peer way. Peer-to-peer may refer to both the way according to which energy transactions take place and to the information architecture supporting them. Blockchain enables peer-to-peer transactions in a decentralized way, perfectly fitting with the idea of making energy transactions without the need of a central authority. Also, blockchain can offer a platform to host transactive energy markets where prosumers can directly buy and sell energy with each other. The decentralized control essential for transactive energy is analogous to the decentralized consensus of a blockchain, and both share the target of opening and democratizing markets. The main advantages of a decentralized architecture over a centralized one are in terms of scalability, resiliency, adaptability, fault tolerance, security, and trust. In this slide, we can see the implemented transactive management infrastructure to enable peer-to-peer transactive energy exchanges. The solution is neither fully decentralized or centralized, but it's organized into hierarchical layers that interact with only with the neighboring layers above and below. It consists of a data center owned by a central actor that can be the aggregator. It can thought as a virtualized set of servers which are centrally managed by the actor. The communication layer, consisting of all components need to let the controllers to communicate with one another, and the user layer where the controllers can execute some demand response algorithms to and perform all communications. To implement this distributed parallel optimization and allow the exchange of energy data among all prosumers, distributed intelligent devices based on information and communication technology should be used. It has in particular been used that all prosumers are endowed with the home device gateway and a smart meter, allowing near real-time communication over the energy data flow, and an energy management system, which hardware device such as a Raspberry platform. The management system platform based on the ICT, on the information communication technology and software application, is also required to evaluate the absorbed and injected power for all prosumers, and for the exchanging of information between prosumers, and for managing all the batteries. In particular, we further developed this architecture for the considered large-scale aggregation of prosumers, where we have that each local energy management system can perform a local optimization. In particular, in this case, we have a layered architecture also consisting of a physical layer and a virtual layer, which is essentially a virtual platform where all prosumers can access. The physical layer provides grid connections, smart metering, and communication to all prosumers, while the virtual layer also includes an energy information system, allowing local site awareness based on real-time monitoring and on tool for forecasting of photovoltaic production and load demand. By accessing to the virtual layer, prosumers can exchange only some privacy-preserving information related to their local optimal solutions, and their power flexibility contribution to fulfill the some global constraints that I will show later of the global optimization problem. The virtual layer is based on distributed ledger technology and on smart contracts to achieve both the AI and real-time optimization. In particular, we're looking at the mathematical formulation for the day ahead. The aggregator aims to maximize the remuneration, shown here, the remuneration due to the provision of energy flexibility in the ancillary services market, while minimizing the cost for the energy from the power grid. There are two global constraints that should be considered for up and down regulation, in particular the aggregate should provide an energy flexibility by respecting a constraint on the minimum power that is calculated considering the related baseline. And also there are some other local constraints related to the power balance for each prosumer, the power limits from to the grid of each prosumer, and the power charging discharging speeds for the batteries. If the offer is accepted by the system operator, then the aggregator should guarantee the provision of the amount of flexibility in the time ranges defined by some discrete variables that define the time ranges. And the optimization problem is very similar to that of the aid, but we have these equality constraints in order to respect the energy flexibility accepted by the system operator. The discrete variables related to the time ranges can be identified during the day ahead, both in a centralized way by using a mixed integer linear programming optimization, or in a heuristic way by using a new method based on a new two-stage method based on hybrid neighboring search and on distributed parallel optimization. This is because the centralized formulation is not able to deal with the extra large instances arising from real-world scenarios, and instead, by solving the problem in a heuristic way, we can achieve a distributed parallel framework in which all prosumers participate in solving the problem in a faster way, also keeping their information not disclosed. The way we accomplish this mission is by breaking down the centralized problem into many linear programming formulations and solving the resulting linear programming problems in a distributed parallelized way. In particular, a new distributed optimization method based on linear programming is designed to overcome previous methods based on integer and/or quadratic programming, such as alternating direction method or multipliers. The proposed method is scalable, allowing to deal with hundreds of thousands of prosumers in real time. It is privacy preserving. In fact, a global solution can be found without any prosumer knowing the behavior or objectives of any other one, and it can be implemented by using the described architecture, where each prosumer performs an optimization based on its specific objective function. As regards with the distributed parallel linear programming based optimization, the idea is that of distributing optimizing this objective function, minimizing this objective function, and the idea is that of distributing this is subject to these constraints. The idea is that of distributing the global constraints among prosumers in such a way so that the minimum power flexibility contribution of each prosumer is determined by the energy reserve available in its battery according to this equation, and to solve this optimization problem where the update of gamma, the vector gamma, is achieved in the virtual layer by a smart contract. The basic intuition behind this formulation is that we increase the weights of gamma by larger amount on those constraints which are more violated. It's worth noting that the privacy is preserved as the aggregator has only to update gamma, and he only knows for each user the product A of the matrix A bit A and X and vector X. Now I will first show some results obtained by considering the centralized optimization. More results can be found in this paper. More the details on the method. In particular, we can see here the studied large-scale aggregator, the aggregate consisting of 2,000 residential users. All of them are endowed with a controllable photovoltaic battery system. And in this figure, we can see the state of charge of the battery during one day in April. In the case of up regulation, we can see that up regulation is provided between 2 p.m. and 6 p.m. Here we can see in the lower part of this figure, we can see the average power in a quarter of an hour related to the photovoltaic production, the absorbed power for the baseline, this dotted line, and the absorbed power in the case of upper regulation. Then I show now the results obtained with the innovative, scalable, privacy-preserving distributed parallel optimization. More details can be found in this paper. In particular, here we can see the results considering 2,000 prosumers that satisfy the flexibility constraint of 1 megawatt. And we can see here the baseline, the results of the centralized and the distributed optimization. And we can see that if compared with the decentralized optimization, the proposed DAID parallelized distributed optimization can achieve the same flexibility in terms of delivered energy in mentioned period. And also, when considering DAID forecast error of 20% for electrical load and 10% for photovoltaic production, here we can see the absorbed powers related to the DAID real-time optimization. It's worth noting that regardless of the forecast error, the parallel real-time optimization can achieve a power profile very close to that accepted during the DAID in the ancillary services market, thus not incurring in any penalty. Now, then, here we can see that when considering that the computational time of the proposed approach by varying the number of prosumers, the proposed approach is highly scalable, allowing to deal with hundreds of thousands of prosumers in few seconds. It is worth noting also that for real-time optimization, the time varies between 30 and 25 milliseconds during the year. Now let's move to the final comments. I would like to highlight that linear programming-based parallelization enables not only to perform in an almost real-time way for very large-scale real-world problems, but also to fulfill the privacy of prosumers. Both the real-time optimizations, being highly scalable and able to protect the personal information of prosumers, overcome typical drawbacks of centralized methods. The proposed linear programming based optimization methods can be easily coded up and implemented on microcontrollers and connected to the implemented architecture. Here you can see a list of further selected readings on this topic. Thank you very much for your interest and attention. If anyone like more information or his question, can contact me by email. I would now be interested to hear from you with your comments and thoughts. Thank you very much.
So we have questions. Someone is asking, is the algorithm ensures scalability also?
Yes. The method, as I've shown, is also highly scalable, allowing to deal with hundreds of thousands of prosumers thanks to parallel optimization.
And further, somebody is also asking, what is the contribution of the presented work in the era of smart grid?
Yes, the contribution is that of proposing an innovative solution to deal with large number of prosumers that are endowed with photovoltaic systems and battery system, and can provide flexibility to the smart grid in the ancillary services market. And also the method being based on linear programming is very very fast if compared to previous methods, and can consider a large scale number of prosumers.
Thank you, sir.
Thank you so much,
Welcome.
Professor Ciano, for giving us the time to be accepting our invitation for this keynote speaker. I welcome Professor Vineet Kansal to please have some words for his session.
Thank you, Oviano, for joining us and to our research collaborations, and hope in the time to come and with the opening of the national educational system, we may have some research collaborations and some student exchange program as well.
Yes,
thank you very much for joining us.
Thank you, my pleasure. Thank you very much.
Thank you, sir.
Thanks.
Sir, Anindya Bose sir is also with us. Anindya sir, if you can please unmute yourself. Thank you, sir.
Yeah, hi.
Hello, sir.
Hello, sir.
Hello, everyone.
Moving forward, now I would like to welcome Mr. Anindya Bose to add glory in this atmosphere. Mr. Bose is presently working as a senior publishing editor with Springer Nature. He is the part of the global acquisition team at Springer and responsible for acquisition of scientific content across the globe. The disciplines he is responsible for are chemistry, material sciences, earth sciences, and computational intelligence. He has more than 24 years of industrial experience in marketing and different fields of publishing. Mr. Bose has completed Masters in Organic Chemistry from Delhi University and Masters in Marketing Research from Symbiosis Institute of Management Studies, Pune. He has delivered more than 60 invited talks on scientific writing and publishing ethics in reputed universities, international conferences, and author workshops. He has published books for secondary level in chemistry and is a member of American Chemical Society, USA. It is my honor to invite Mr. Bose to present his visionary words on topic Elements of Book Publishing.
Hi, hello everyone. Thank you, Muskan. I hope all of you can hear me well.
Yes, sir.
Yeah, thank you. Good evening, and especially Saturday evening. It's a holiday weekend, so thank you for attending and still being here. I think the symposium started well in the morning, and it is quite good that the sessions are going on, and already you had 2 keynotes back to back. Third one is mine. So I will not bore you anything with all these, thank you and welcome and all those things. It's been said, I think, again and again many times. Let me just share my presentation over here so that we can straight away go to the slides and talk about today's topic. I think you can see it, correct? The slides. It's visible.
It is
Yes,
visible.
sir, it's visible.
Okay, great. See, I thought of talking about elements of book publishing over here. The reason is very simple, because in past 1 year, suddenly there is a flood of book publishing, flood of books. Everybody, I don't know what happened to the academic world, and everyone wants to publish book, and everyone wants to publish edited books and all monographs also. There are so many books are coming on in COVID and all those areas, so suddenly everyone wants to know about what exactly, how to publish it, what all steps are involved. So I thought it is a good platform. This is a doctoral symposium. People who are already doing PhD, they are here, and they can, very well think of writing something for book publishing also beside journals. So why not talk about the steps of book publishing which are involved in it, and certain other services, and what all things what we do, and how these academic publishing works. So that will give you an idea how this whole thing is working, and what are the steps which are involved, that will help you to plan also. So little bit about the company from which I come from. You all know Springer very well, and people who are doing research, they know this logo very well, the horse, which is which started in 1842, this company, by the person, you can see the photograph over here, Julius Springer. He started this in 1842 in Berlin. Started as a small bookshop, although at that point of time in 1840s, there were no proceeding publishing, and people were not coming to conferences to publish their work. They were more, coming to conferences to discuss their work, so that they can get a lot of feedback, and then these feedbacks and these revisionary comments, they can use to improve their work. Especially, we are one of the late movers. Springer moved very late from Berlin. It took them some time. After the First World War, we opened our first office outside Germany, that is in Vienna. Then after the Second World War, we has opened one of the biggest office, which is in Heidelberg, which is the biggest editorial office we have till date. More than 1,000 colleagues, sit there. And recently there is a change. Recently you must have seen the name has changed to Springer Nature. This has happened in 2015, and Macmillan Science and Education merged with Springer. So the name has changed to Springer Nature, and now we have 10,000 plus colleagues, from 50 different countries we are operating. So if anyone wants to publish with us, they can actually look forward to, because you can go to the springer.com page, and immediately you can go to the contacts column, and you can find someone in your country who is representing Springer. Springer Nature's role in academic book publishing, if you look at the academic book publishing, because we publish academic books, we don't publish other type of books. So we are one of the largest publisher in that domain. And especially if you look at science, technology, and medicine, we are doing it for quite some time. We started with engineering and mathematics when we started Springer. But eventually we moved to technology and medicine, and then all different, subjects of science. Very recently, because if we look at those numbers, like in 30 years or so, we have moved to humanities and social sciences. And especially with this merger in 2015, Palgrave, people who are from social sciences background or behavioral sciences background, they know Palgrave very well. That is another company which has been merged with us. So we are doing a lot of books in humanities and social sciences also. We publish on an average 13,000 new books each year. That is a very big number. And interestingly, that number has grown phenomenally last year. We have almost published 15,000 books last year. That is maybe because of COVID. I don't know what is the reason, but I practically think that academicians, they had a lot of time in their hand, because they were not taking active classes, or they were not going to the labs for doing their work. So they had time to write books. So the number of books have increased. We have our two portals, springer.com and Springer Link. So we have almost 3 lakh books which are available as online. And that online presence of Springer has really helped Springer last year during this pandemic to reach the readers, to reach the audience very well. So we are one of the pioneers in digital publishing. We started long back, in 1995, we started with journals. And in 2005, almost 15, 16 years ago, we started with digital publishing of books. So whatever books we are publishing are also published in multiple formats. I will talk about that in a bit. And that is why we are one of the pioneers in this digital book publishing area. Let us talk about steps of book publishing. I will talk about this to make you aware what all steps are basically involved in book publishing, how you can publish a book, what all things are needed so that you can approach a publisher with the correct documents, and it is easy for you to understand the process also. First step is the something which starts with an idea. Everything starts with an idea. Similarly, book publishing also starts with an idea. When you have a great idea or a good idea, then you can actually write something new for future readers. And if you have a unique idea, that really fills the gap in current literature. That is very important, because when I say that you can fill the gap in literature, then I always give this example of artificial intelligence. You think about this topic and you can see that artificial intelligence is there in every aspect right now. In every discipline, people are talking about AI. And suddenly in last 10 years, when data became the most important thing and the availability of data is something which is in abundance. So people are talking about AI a lot, but AI has not started 10 years ago. AI started 60 years ago. The term was coined in 1960s, and we have a literature of 60 years for artificial intelligence. So when we talk about literature, so over these 60 years, there may be many gaps in those literatures. So definitely, if you have something unique to fulfill that gap, that is something very important when you are actually thinking about to write a book. That actually helps you to reach your audience very well. Second, and the most important step in this publishing book is basically how to formalize this whole idea which you have into a proposal. There are certain things which are needed to create that proposal. And what all these things, I will just tell you. First and the foremost thing is your CV, is your biodata, your profile, and the list of publications which you have. That is very important, because when you submit your work to someone, then it is easy to assess your position or your status by looking at the kind of publications you are doing and the list of publications you already have. Then the important thing is synopsis of the book. Synopsis of the book is actually about the book. About the book is something which is very, very important, because I want to emphasize over here that when we receive proposals even from senior authors at times, they do not write about the book. They always write about the subject. This is something which is very, very different. Why I am stressing on it, because suppose if you talk about a book like Applications of Machine Learning. Now, there are many applications of machine learning, and you may be talking about certain applications in your book. So the reader who is actually reading about the book or synopsis of the book wants to know what all applications you are going to talk about in your book, what all areas you are going to actually write about. So we don't want to know about machine learning as a whole, but people, when you ask for them to write a synopsis, they write 2 pages on machine learning. They don't write anything about the book which they are basically proposing. So be very, very particular about what exactly a synopsis of the book is like about the book, what exactly you want to write about the book. Then it comes table of contents. Table of contents is the structure of the book. Structure is basically how you are dividing the book into chapters or into different areas. So that is very important. A detailed table of contents always helps the reviewers to understand your book well. Then it is sample chapters. Sample chapters is also sometimes confusing for some people. They do think that sample chapter is something which they have already written or they have already published. No, it is not. Sample chapters are the chapters which basically you are proposing for the current book. So maybe, it is not a final draft. There's always a possibility, but the sample chapter should be 75% ready. That is something which will talk about the objective of the book, and people will understand the quality of your work, what content is basically present in your work. So these are the 4 things which are very important when you are actually changing your idea into a proposal. Your CV, synopsis of the book, table of contents, sample chapters. Then you send all these things to the publisher. Whosoever is the person sitting on the desk as a publisher, first thing, they evaluate the proposal, they check the proposal, and they have a checklist. They put the checklist in front of them and they see all these things are there or not, which I already said in my previous point. Like, these are the 4 things which are important. Once it is fulfilled, your work is moved to the next stage, like peer reviewing. Peer reviewing is basically review of the work. You know very well, peer means people who are already working in your area. They are going to the experts who are working in your area. They are going to review your work, whether the work is good, whether the work is needed, whether something is there which they can actually comment upon. So there is a peer review of the content. Once the peer review is done, then it is acceptance and contracting. This is a formal, agreement between the authors and editors and the publisher. Once this is done, you always receive an author package. Author package is nothing but certain templates, certain copyright forms, permission forms, certain things which will help you to actually build on your manuscript, which will help you to write your manuscript. So you receive the author package and then you create your manuscript. So from evaluation, peer reviewing, contracting, you get the templates, and finally you create your manuscript. 4th stage is you share your manuscript, which is in the ready form according to the contract which you have with the publisher. Now your manuscript is moved to the publisher. Usually this manuscript is in, I will say 99.9% time, it is in electronic form or digital form. We don't accept the handwritten forms anymore. Previously, it used to be in handwritten form. So once we receive the manuscript, we do certain immediate checks. These checks are like, first thing, we check the plagiarism of the manuscript, whether the content which you have submitted, is there any similarity of that content with already published work. Then we see the ethical aspects also. There are certain images which you have used, or figures which you have used, or the tables which you have taken, maybe your work, maybe someone else's work, whether you have taken permissions or not. That is also very important. And third thing is, there is a team, back-end team, which actually reads the content quickly. They glance through the chapters and they see what kind of a language it is. In case the language is not good, then we immediately go back to the author and tell them. So these are quick checks which we do once we receive the manuscript. Upon receiving the manuscript, if we find everything is correct, then we move to the next stage and we create the XML file of the book. XML file is the tagging of the book. It's a digital tagging, because the book is going to be published in different formats. As I said, these formats are like the print format, and different formats for different gadgets. Like, if you have iPad, you need a format which is EPUB. If you have Kindle, you need a format which is PRC. Now, you don't know these formats, but we have to create these formats so that you can read them on your gadgets. So we create an XML file, and from XML file, different formats are created. So when we actually say that your book is published, the book is published in different formats at the same time. And that is why usually it takes 12 to 16 weeks, time to typeset everything, to check with the authors, revise things, check the proof, and finally it gets published in different formats. Let us come to the 5th and the final stage of step of book publishing, and that is actually how your book is going to be shared with the readers. That is something which is very important. When you write a book, you be very, very sure you go to the publisher's pages, you read about what kind of a book they are publishing, you see what kind of books they have already published, go through them, and then only look for a good publisher. It's not that something randomly you just want to publish a work and you go and publish. It's not necessary that it's important that you check the details. And dissemination is something which is very, very important. How we are basically taking your work to the readers, and Springer is very good in dissemination, and that is why we are one of the leaders in book publishing. You can see on the slide there are certain websites which are mentioned over here. One is springer.com. Springer.com is basically a website where we talk about the book. There is a dedicated web page for each book we publish. We have the sales informations given over there, like about the book, about the editors, ISBN numbers, and all those details, the price and everything. But the content is not available on springer.com. Content is available on another platform, which is called Springer Link. And this is the content platform of Springer. And we have almost 10,000 plus institutions which are the members of Springer Link. Now, all these 10,000 plus institutions are not going to, buy your book, or immediately they are not going to subscribe the book. We have a definite way of taking these books to the authors. It's through ebook packages. So when you write a book, suppose for computer science, we have an ebook package for computer science. So the institutions or the libraries who are basically purchasing or buying this package from us, they will get the book and they can get the book in the package itself. So your book can be sold in package and also individually. So there are two possibilities. Besides Springer.com and Springer Link, we have a distribution network that is third parties. We have Amazon, we have iTunes, we have Flipkart, we have Barnes and Nobles. There are many different companies which are, working in collaboration with us, and they are also selling your content. So this is another way of dissemination to a larger audience. And finally, there is something called author support. Author support is a very big team which is working behind, for creating the covers, flyers, and especially the newsletters. Newsletters are very, very important tool for us, because they reach the audiences, they reach the readers. Every month we publish these newsletters. Every month these newsletters are basically, distributed among the academicians in different exhibitions and different conferences. So it is very important that your work is disseminated well. So these 5 steps are very important when we talk about book publishing. That means it starts with an idea which comes to your mind, then formalization of that idea into the proposal. Finally, your proposal gets into a manuscript. By different processes, your manuscript is turned into a book in different formats, and these books are basically taken to readers through different channels, that is dissemination. Let me talk about next is types of books. Types of books is basically what kind of books we are dealing with and what kind of books you can write with us, or what all are academic books. First is monograph. Monograph is especially something which is a book which is coming out of your research, a scholarly book on a single subject, or sometimes, group of related subjects written by single author or group of authors. This is called research monograph. The second type of book is called edited volumes. Now, edited volumes is very different from research monograph. Edited volumes are contributed volumes. You will have authors here also, but these are basically controlled by people who are editors. Editors are basically, they invite contributors to write on a particular theme. They conceptualize a book, then thematically, they call and they invite people to write for them. And the people who are ready to write, they submit their chapters. Finally, these chapters are checked by the editors and a volume is created. Now, I would like to emphasize over here greatly that edited volume is something which is for senior people to write, for senior academicians to write. Why I'm saying this, when you publish any article in a journal, always you will see the young scholars, PhD scholars, or the young faculties, they write original papers. Review papers are something which should be written by senior people who are in the industry for 15, 20 years, who have the capacity and the authority to write a review on another work. So similarly, edited books function like that. You should be in a capacity to understand the work, in a capacity to edit someone else's work. So I will say that the people who are young scholars should write research monograph. They should not think of writing or collecting papers and create edited volume, which is quite a trend right now and which is very, very wrong. You must have seen there are hundreds of calls for papers are there on social sites, on WhatsApp, on LinkedIn and all. And this is not the way you should actually write edited books. Call for paper should be for the different purpose, should be for a different purpose. It is for proceedings. Call for papers are basically for proceedings, which is a collection of academic papers which are presented in conferences, congress, symposium, workshops, and all, like the one which you are attending right now. And you must have submitted a paper over here, which is reviewed by reviewers. And finally, a decision has been taken by people, organizing committee or the editors, to publish this work. So these are basically something where call for papers are written for. Don't go for call for chapters. edited books are not meant for that. Edited books are much, much better than that, you know. Professional books are basically written by people who are in industry or people who are basically in commercial aspect. They write manuals, they write guidebooks, data compendiums, and these are very effectively used by different academic people and written by professionals. So these are professional books. Then you have textbook. Textbook is basically a course book. You all know this is a subject syllabus based book on certain subjects, and these are basically used for schools, colleges, and universities. So we don't claim, Springer never claims that they are textbook publishers, but interestingly, our contribution is like 4 to 5% of what we publish. So 4 to 5% of 13,000 books is again a very high number, and this number is maybe bigger than some textbook publishers. So we don't claim that we are textbook publishers, but we also publish many textbooks. Then there is something called reference work. Reference work are basically multi-volume works. You know, these are on specialized discipline like encyclopedia, which is talking about everything about that subject or a topic from very basic to the tertiary level. That is called reference work. There is another kind of reference work which are called handbooks, and this is a very specialized books which are, you know, published by Springer. We have almost a 40 to 45 handbooks only published in these years. So many years we have only such small number of handbooks, because these are again reference work, but these are single volume work. These are like written by the experts in the area, and it's a concise compilation of methods of research and principles and functional relationships in a particular subject. Then we have something called Springer Briefs. I will just tell you about this. This is something which was started almost 10 years ago. This started because, you know, we have realized that there are many authors who want to publish their work quickly. There are many authors who are first-time authors. They cannot write big books, and there are research which needs to go to audience in a quick manner, maybe 80 or 100 pages, but you cannot create a 80-page article for a journal, and you cannot create another book for 80 pages, because monographs are usually 200 to 250 pages. So, you know, we started with this idea of Springer Briefs, which are like 55 to 125 pages, which are soft cover binding, quick turnarounds, quick review, and copyright remains with author's name, you know, because we see that there is a need for that, because many quick work are basically published over here, and this quick work, you know, they need to go to audiences quickly, but at the same time, there is a possibility that author can extract something and go and again publish in an article or something somewhere some other place. So copyright remains with the author's name. You don't have to transfer the copyright. So this is a very nice type of book which young scholars or young faculties who are first-time authors, they want to write. This is something which you can do. Another type of book, something which we have started very recently, like it's called a video book. This is called Discovery in Motion. Only 2 years ago we started with computer science and with medicine. Now we are venturing into engineering and also to management areas, and we have I think only 200 plus video books right now. If you go to Springer link, you can see there are some video books which are available. And this is something why we have done this, because we have seen that the young brigade, you know, the young research team who are there, or the people who are young scholars, they study a lot from videos. You know, they go to YouTube, they try to find videos. They are now in the year of pandemic, you must have seen that there are so many faculties, they have started with their own YouTube channels, you know. So we thought, why not create a video book where, you know, a small video of 30 minutes or 45 minutes covering a topic. It is not something very cumbersome. It is like 5 chapters divided over 6 minutes each, so that you can have 30 minutes of a video. Here, there's a possibility that your authors can remain in the background also. You know, if you don't need yourself to show over there, you don't need to. Only your presentation is visible. So this is something, a new thing, which all the new researchers or new faculties can think about writing. This is an interesting way of reaching your audience. This is not a type of a book. This is a mode of publication. This is like open access, and I will always ask you to, if there is an opportunity, please go and publish open access. Open access is difficult to publish because there is a lot of, it's an author pay model. There is a lot of funding is required, money is required, but there are a lot of funders available. I will just tell you about them in a bit. Before that, I will tell you, why you need to write open access. You can see in the slide itself that open access books are 2.4 times more cited, 10 times more downloaded, and 10 times more mentioned. When you write a book, your objective is to reach the audience, reach your readers at a maximum level. So when you write an open access book, definitely there are book processing charges, but the reachability is very, very high. There is a page called OA funding support, which I was just mentioning. If you just go to this particular page, springernature.com/in/open-research, then you will find there are many funders are available. There are almost 200 plus funders available all over the globe. And these funders, they can work with you. You can share your work with them, share your ideas with them, and you can ask them to work or fund your work. There is a possibility. Recently, that this is a website which started almost a year back, maybe 9 months back, oabooks-toolkit.org. This is another place where you will find all kinds of information about OA books, all kinds of information, how to approach a funder. And this is another interesting place where you will find all these details, which will help you to approach funders, to approach a right publisher, so that you can actually write an OA book. I will talk quickly about the ethical issues over here. And before I move to ethical issues, I will put some questions to your mind. Usually when I give this presentation physically, which I love to do, I hate giving presentations online because it is just talking to your laptop. So it's like you cannot see the audience, you cannot see them face to face. But I usually ask these questions when I do physically also, and let me just ask these questions quickly so that you will understand what exactly the size of this whole industry and how ethics actually it works. Like, how many papers are published worldwide in a year in English language journals? If I ask you, like, how many papers are published in different subject areas written in English language journals, the number is very, very high. It is like 1.8 million papers published worldwide each year. And last year, I think it was much higher. It reached almost 2.5 million. So 1.8 is just an average number. So last year, because of pandemic, I think number of papers have increased. Huge number of papers have submitted. And in COVID area also, many researchers moved to that area. They moved their area of working, and they have published many papers. So 1.8 million papers are actually published, so you can imagine very well, this is like 30% of papers which are actually accepted and published, and 70% papers are either in revision or in rotation. That means total submission of papers is much, much higher. They are in the tune of 5 to 6 million. That is a very high number. And then how many books are published worldwide? When I ask this question to people, how many books are published, usually people, this is a notion-based questions, people say number of books are always less than number of articles, but it doesn't work like that way. When I did this survey, I read about this survey and I put those figures over here. It was an eye-opener for me also. It is like 2.2 million books published worldwide each year. So number of books are much more, Talking about ethics, my last question over here is, how many researchers in percentage, if you think about, have committed research fraud at least once in their career? So how many researchers have committed fraud at least once in their career? Many times I have seen people talking about very high numbers over here, but fortunately we are working in a community which is very good community. Scientific community is very good community. They are ethical people. They follow ethics. They are disciplined people, so this number is very, very less. Number is just 1.98%. That is 2% of total number. But if you look at the absolute number, I just said 1.8 million papers are published worldwide, 2.2 million books are published worldwide. So you can very well imagine there are how many authors are there. So if you look at 2% of that number of authors, again, you will find the number is very, very high. The absolute number is high, although it looks only 2%. Before moving into ethical issues, I will just like to tell you what exactly is the meaning of retraction. Before this question is, what is most occurring reason for retraction? You know, why there is a retraction and what is retraction? Retraction is something which is only possible because of digital publishing. Before digital publishing, there was no way anything can be retracted. Which is already published is already published. It's already in the printed form and it is already being purchased by readers. It has gone to the audience and there is no way you can take it back. But with digital publishing, this particular thing has started where we can actually take down that paper, remove that paper from online state, and we can retract that paper. Now, if you look at the reasons behind it, you know, the important thing is you have to look at the reason. The reason is honest error. You know, 40% is honest error. That means 40% people are committing mistake without even knowing. This is a very, very big percentage and an eye-opener for us, because usually you will find like the next reasons are fabrication and falsification. They are doing all wrong things. 28% is that. Redundant publication. This is like plagiarism and self-plagiarism, which is 17%. And there are many other reasons. But if you look at the top reason, which is 40%, that means people, they don't want to commit these mistakes. They are not unethical, but somehow or some way they are falling into this trap. So I will ask you to go to this particular site, the logo which you can see over here. You can see what is copyright written in the slide. I don't want to tell you about the description of copyright, which is like, it's okay, you can read it anywhere. But the important thing is you should go to this particular site, COPE, COPE, which is in Committee on Publication Ethics. If you go to this particular site, you will find there are many details available and they're in very, very lucid language, and the details are important for you to know. Then you will be able to understand ethical issues involved in publishing very well. Simultaneous submission is another unethical activity. Why simultaneous? What is simultaneous submission? Simultaneous submission is submitting the same manuscript to multiple publishers. Now you will say, this is my manuscript, I am sending it to multiple people. What is unethical about it? Now, unethical is because you are sending your work to multiple publishers at the time, and these publishers are actually sending your paper for review. And as you have seen, the biggest challenge for any conference or any journal or any book publisher is basically to find a reviewer. Getting a reviewer is the biggest challenge. And if we are basically misutilizing this particular resource, then it is unethical. So there's a waste of time, waste of effort, and waste of resource on the part of publishers if you are doing simultaneous submissions. Then there is multiple submission. Multiple submission is meaning, sending several different manuscripts to the same publisher. This is also wrong. This is something which is very, very wrong, because if this is basically, you will find this is possible in case of a special issue where you have seen the guest editor is submitting their work, 10 papers, 5 are coming from the same group of people. Or sometimes in a conference, you will find it's a conference and papers are coming from same set of people. So you can very well go and check the content before your submission to any conference or before submission to any journal, how they are basically dealing with papers. Is there any multiple submission involved in it, or simultaneous submission is there? Then it is plagiarism. Plagiarism is something which is very derogatory word. If you say to someone, people will be very, very taken aback. The people will be hurt. So we use the word similarity. We use the word overlapping. These are the words which we use, but people don't get offended with these words. So we smartly use them. Plagiarism is something which is a big no. And what is a fair use is something where you will find a document like Association of Research Libraries 2012. If you type this on Google, you will find a document which tells you about the fair use of how you can fairly use the content from anyone else's work. How are we alerted to plagiarism? How we get to know about plagiarism? There are different ways. Like the original author, sometimes the author finds, okay, my work has been plagiarized, stolen by someone else and published. Sometimes by reviewers. It's very seldom, because reviewers, they review the content, they don't check the plagiarism as such, but sometimes they also alert us. And especially we get to know from people who are whistleblowers, the readers. They read the same content at 2 places and they come to know, okay, this is something which is a wrong thing, unethical thing, and they also alert us. So we know there is a tool which can actually help you to find plagiarism, but I would say it can not identify plagiarism. The tool is there basically to tell you certain similarity index numbers, like only a human eye, only a subject expert can tell you whether the work is plagiarized or not. This is the inside story, how it looks. This is how Authenticate looks, because I can give you the screenshot because we use Authenticate in Springer. This is how it looks internally. This is the a very colorful, you can see, but colorful papers are not good because this is a highly plagiarized paper. As you can see, the similarity index is 93%, 39% coming from a single source again. So these are very high. So there are some quick tips which I will give you. The tool cannot detect all problems. It is important to know the tool can give you certain numbers, and a human intervention is required. A subject expert can come and play a role and understand. A low similarity score does not mean there is no plagiarism. Now, how I will give you a quick example over here. Like suppose there are two articles, X and Y. X has 30% similarity, Y has 10% similarity. Now, if you look at the similarity content, then X with 30% is more plagiarized and Y with 10% is less plagiarized. But maybe you go deep into it and you will find this 30% is actually divided over 30 different sources, and this 10% may be from a single source, direct lift from some work. So this 10% plagiarism is more problematic than 30%. So a low similarity score does not mean there is no plagiarism. It is important to look at the individual score or the sources. Then you will find, okay, so a subject expert can look at those numbers and take a decision, take a call. So setting a standard, it is very difficult. You know, many times editors, authors, they come back to us and then say, what is the limit we should fix? There is no limit you can fix, and we cannot have this fixing of limit. Then it is misusing the tool. Only publications by participating publishers is possible. You know, something which is not published in a digital form or not a part of cross-check database, then it cannot be checked. You know, which is published in a printed matter, printed form, cannot be checked by a digital tool. Common phrases are not excluded, like descriptions and all. You know, like many algorithms, sometimes you are using them, sometimes review paper have more things are there. So you cannot, common phrases are not excluded when we are checking with a tool. We have taken permission. Maybe you have already taken permission for the work, but tool is not aware of that. Tool will highlight that. So subject expert can only see, okay, the permission has been granted. Review articles, as I said, for review, do a check. Review articles will always have more similarity. Patchwork plagiarism, very difficult to find. Patchwork is something many people are using this technique, and this is something very unethical. Please don't do this. And it is very difficult to at times find this patchwork plagiarism also. Self-plagiarism is something which you have already published somewhere and now you want to publish the same work again. So don't do that. You know, you can refer your previous work. If you are publishing the same work again, then it is self-plagiarism. That means taking the content, same content, you know, publishing again. So that is unethical. As I said, data fabrication and falsification, which is like 28%. This is again something which is because of internet, things are available easily, so people are doing it, but this is something which is unethical. So general advice is verbatim copying. When you are verbatim copying, please put things under quotation marks, and you should see what exactly is the permissible, what is the fair use. Give credit to original author. Please don't ask for permission directly to the author. You can write to publisher, because publisher knows more than authors how to give this permission much, and you can get it much easily. If you are using any figure or any table from your work or from someone else's work which is already published, always take permission and then only go for it. Like I will tell you how to take it. Like this article is published in Springer, and this is something which is written about the article. Over here there is a small button link over there, reprints and permission. If you go to reprints and permission, there's a new page which will open, rights link. You answer certain questions over here, and then you can get back the copyright for again, you know, using that work again. So always take the permission back and then use it. Quickly, I will take 5 minutes and I will finish my presentation with author services and publishing tools, which I will tell you. These are the tools which are available for you, freely available, which you can make use of. This is called Reviewer Finder. Now, many journals are basically asking, you know, for, you know, mandatorily providing the details of reviewers when you are submitting a paper. So this particular tool, which is there on Springer, can go to this particular tool and make use of it. This is Reviewer Finder. You can find reviewers. Then there is a tool called Recommended. Recommended is something which will recommend you the articles which is published in your area. Very nice tool, works on almost 45,000 journals. And especially when you get, this is a free tool. When you register yourself, ask some questions to you about your area and all. So in case there's a paper published in your area, so you will get an alert mail, because I told you there are 2 million papers are published in the whole year. That means 4,500 papers a day. It is impossible for you to go and search. So, but a machine can search, a tool can search for you. So if you go and register in Recommended, it will really help you. Overleaf is something many academicians are using, and they are using this very regularly with their students and all. This is basically for collaborative writing and publishing. They have a lot of schemes for developing countries. And many times this is a paid thing, but many times they have a lot of schemes available, so you can make use of this particular tool or particular website. Shared it is something when you publish with Springer. When you publish a paper with Springer, then the production team sends you a link which is called Shared It. You can actually send this link to everywhere. You can share this link on your the social site, and you can send it, keep it on, send it through mail to anybody, so that they can read your paper completely. They don't have to download, they don't have to print it, but they can read the whole paper. This works in a reverse way very well. Sometimes, it happens that you go to springer.com, you want to read download a paper, and you can see that there is a subscription is not there, and you cannot download that paper. So you don't have 25 euros to buy every paper. So what you can do, you can write to the corresponding author and ask them to share it with you. So legally, they can share the paper with you, and you can have the access of the whole paper. Shared It is a fantastic tool. ORCID, usually I tell this to all my Indian researchers that this is like an Aadhaar card for people like researchers. If you don't have an ORCID ID, please go and have one, because this is very, very important. This gives you the uniqueness to you, and it helps in your citation, proper citation of your work, because an unique ID is basically given to you. So if you don't have this, please go and register. The source is, this is a blog which is very, very actively used by many researchers. And if you are not doing it, you can go to springer.com and you can use this. This talks about many career aspects, many areas which are very important. You can also submit your own blog, and you can communicate with your community. Before I conclude, I will talk about 4 books over here. First one is How to Write and Publish a Scientific Paper, which is written by Robert A. Day and Barbara Gastel. You can see the image of 8th edition over here. 9th is, I think, already out, and 6th is already available free on internet. So you can go and you can download. This is something which is a book which should be there always with the researchers. They can refer back to this book again and again. There's another one which is called Getting It Published, which is written by publisher himself, William Germano. So this again talks about all the nuances of publishing, and you will get to know many details. And these are the 2 books which you can refer back again and again. There are 2 more books over here, which is, one is Textbook of Research Ethics, which is written by Sana Lu. This is used as a textbook in many universities. This is a good book because ethics is something very important and close to my heart. People should be disciplined enough. They should work ethically. And the last one is Engineering Research Methodology. This is published 2 years back by Dipankar Dev, Rajiv Dey, and Valentina Balas. And this is another book which is very, very good book for engineers. So before I say thank you to all of you for giving me this time and honor and time in Saturday evening to listen to me and work sincerely, focus on quality. Say no to academic corruption. You know that every field has corruption. You know corruption is there in academics also. So stay away from those corruptions, stay away from unethical activities, and stay happy. Thank you very much. If you have any questions, I can address them. My email ID is written over here, onindo.bose@springernature.com. If you have any questions later, when you use those tools, when you want to write a book, or you have any questions which are coming to your mind later, you can write to me. I will be very happy to address them. Thank you. Thank you so much.
Thank you so much, sir, for this wonderful session. And it is really very nice that we are hearing you after such a long time. We missed your talk in at ICICC, and
Yeah, I know.
means it is really enriching for all of us to hear you at on this on Doctoral Symposium. Sir, I have one or two means not exactly. I will say the conventional questions maybe you would like to answer or not, but still the authors have sent to me.
Yeah, please.
So I have a question means that he's asking that as the India is a developing country and as some international publishers are doing case on SCI Hub, which is making the research papers available free of cost. What is your take on this as a representative of one of the leading international publisher? I am also repeating the second question because both are same. Why not Springer come up with some special packages for Indian and other developing nations where they can access the quality research at an affordable price ethically?
Yeah, they very, very good questions. And I know these are difficult questions to answer, because when you talk about something free, it is very difficult to provide things free, you know. But everybody is going towards open science, and open science is something already on the desk. And I can tell you that Indian government is very, very keen right now. We are having a very, very, this dialogue is going on almost for more than a year right now with government, and many publishers and many other stakeholders are involved right now with that. And this is something which is like, read and publish sort of deals, which we are doing with many other countries, like in Netherlands, in Scotland, in Germany. These type of deals have started. In India, we have just started it, 6 months back with Manipal University, which is the Manipal, the parent one, which is there in that they have started with us for open science thing. It's called read and publish deal, where open science is available, where you don't have to pay that much, where the content is available to you and government will pay for you. And that is the some sort of dialogue is already going on, and I am very hopeful that this will be done in near future. And the current government is very, very doing very hard, working very hard on this particular area, and they have actually involved a lot of stakeholders to take a decision. And I hope by end of 21 we will have something very concrete, where the research is, it cannot be free because someone has to pay for something, but definitely, the accessibility or the access for a country like India, where it is still developing, we know, we cannot have that much of fund available for everything. So science will be available in a much better form and in a much better, volume, quantity also. So that I can assure you, the work is already in progress.
Thank you so much, sir, for this valuable information.
And sir, someone is also asking why the researchers are not paid for peer review.
This is a good question. Again, it is always good when you look for payment. This is not something which we haven't done. If I will tell you, many good publishers have already explored this area, that for paying reviewers. But this never worked. Somehow I don't know why this never worked, because we thought of giving access to people in different ways, free access of books or free access of journals. And we try Elsevier, I come from Springer, but I can tell you that Elsevier have started this long back, paying reviewers, but things never got materialized. But reviewers do not review for money. That is why this community is so good, because reviewers review work to make, make themselves updated. That is why they go and they review the work. That is why they want to give it back to the community. It's not that, that small amount of money you want to, get by reviewing something. It is something where you can also give back to the community. So we have already explored these areas, but this never worked with us, and I can tell you that when we started paying reviewers, many reviewers, they refuse. It's not that every reviewer or many authors, they don't even take royalties. It will be very, very eye-opening for many people. You know, they refuse to take royalty even. They said, okay, no, this is something which we are doing for the community. Let us not earn, you know, this is something, my gift to the community. So we have already explored these areas and we have seen them. You know.
Sir, Professor Vineet Kansal is on. Yeah.
Yes, yes. Sir. Hello, Kansal sir. Hello, how are you?
I think some connection has broken.
Yeah, some network issues must be.
Yes. Vineet sir, your voice is not audible on our side.
I think it's frozen right now.
Yeah. Muskan, if you have any other question from the audience side, you can ask.
No, sir, not yet. So you can please drop your email ID because a few of them are asking like if we can turn the mic on.
Our authors are
So
in
that would be better that if
they are
you
writing
just
a lot
type
of
the email ID.
Okay, I will just give my email ID to everyone. Just
in case if the authors have any question, please kindly just write it down. We are receiving the questions and we are asking them directly. This is important for us. We are really sorry for that in case we have not allowed you to.
I'm sorry, I missed my connection.
Yeah, yes, sir. Please carry on, sir.
Am I loud?
Yes, sir. Hello, hello, Kansal sir. How are you?
मैं बढ़िया हूँ. आप कैसे हैं? After a long time, actually.
Yeah,
and
after a long
it
time.
was again your presentation has been so thorough and meticulous. I was talking about, you know, many of the questions should be taken to the Kaun Banega Crorepati. Really the people who are into the area of research are not knowing the difference between monograph, books, edited books, volume, published book, many things. It's really an eye opener. I think some of the questions should come to the debates and to the research foundation basic courses, to the 4-year degree programs. I think it's very, very much needed.
Yeah, I know.
I think it's really commendable. And I think Corona also has given us an opportunity. As you said rightly, you know, 2,000 more books have been published, 13,000 to 15,000. So
Yeah.
it's really an opportunity for many people who have utilized this, you know, time as a time for, you know, creativity.
Correct, sir. Correct.
So I look forward, you know, to work more together. And I think the people who have listened to you, who have been very, very patient, though being a Saturday afternoon, as you said, it was not at all boring to hear you. And when you speak, a lot of vibration, you know, and a lot of compassion which you have it, I think it makes more meaning and you know, depth to listen to. So really, I'm thankful for associating and backing this conference too, and look forward, you know, to cherish it further for the quality work to produce. Thank you very much, Mr. Anand.
Thank you. Thank you so much, sir. Thank you so much.
Thank you so much, sir.
Thank you, sir.
The next distinguished to honor us with his presence is Professor Manu Malik from Alcatel-Lucent Bell Labs and Stevens Institute of Technology, New Jersey, United States. Professor Manu Malik is the editor-in-chief of Elsewhere's International Journal of Computers and Electrical Engineering. He was a distinguished member of technical staff at Lucent Bell Labs until 2001, then joined Stevens Institute of Technology as Professor of Computer Science and Telecom Management, from which he retired a few years ago. He has held various academic positions in the USA and overseas, as well as technical leadership positions at Telcordia Technology and Lucent Bell Labs. He is the author, co-author, or editor of 7 books and numerous publications in the areas of communication network, computer communications, and network management. An alumnus of University of California, Berkeley, Dr. Malik is a life fellow of the IEEE and an IEEE Third Millennium Medalist for his contributions. He was editor for network management of the IEEE Transactions on Communications and an IEEE ComSoc Distinguished Lecturer. He founded and was the editor-in-chief of Springer's Journal of Network and Systems Management. Dr. Malik is a frequent invitee as keynote speaker at international conferences. His favorite topic is information security, with the subtopics of IoT, security forensics, and defense and autonomous vehicles. I am pleased to welcome Professor Manu Malik, and today he will be sharing with us his expert opinion on IoT applications and security.
Thank you for the introduction. Can you hear me? All right.
Yes, sir. You're audible. I welcome you, sir, Professor Manu Malik. Actually he's in US, and it's I think in the morning 7 o'clock at your end. So it is a great honor for us to have you as a keynote speaker, sir, in our symposium.
Well, thank you. Thank you for inviting me. Let me see if I can bring this up and share the screen. Okay. Okay. Let's see. Do you see the screen now?
Yes, sir. It is visible.
Okay. All right. Let me put it in this mode here. Okay.
Yes, sir. Perfectly visible, sir. You can start.
Okay, great, great. Well, let me start by thanking the conference organizers for inviting me, in particular, Dr. Deepak Gupta for facilitating it. And let me also mention a word about computers and electrical engineering, which is a 50-year-old journal published by Elsevier Publishing, indexed in many indexing services. We publish papers in on many important and state-of-the-art topics like security, artificial intelligence applications, IoT, cloud, fog computing, e-health, smart grid, and so forth. And in fact, Dr. Gupta has been a guest editor of several special sections for the journal. We receive more than 3,000 papers per year with an acceptance rate of less than 20%. So let me go to the next one. Okay, the focus of my talk, two focuses actually. One is IoT and information, the other is information security. I'll start with a quick review of the evolution of the internet toward IoT, and then discuss some applications of IoT, in particular autonomous cars. I will go over some trends of affecting information security and then offer some solutions for security, in particular for IoT. Well, about the evolution, I'm on slide number 3 in case you're following. Excuse me. The internet is a global system of interconnected computer networks, which was introduced in the early 1980s as an outgrowth of ARPANET, which was a US Department of Defense project. In fact, when I was at UC Berkeley, I had actually a project working on this. The World Wide Web, which was introduced in 1989, provided easy access to the internet via the web browsers. Now, we use the internet daily for many online services. We use it for communication, finding information, doing transactions, as well as for entertainment. And this is possible independent of location due to its openness and distributed nature. Wireless sensor networks and ad hoc networks came about in the late 1990s. Wireless sensor Networks refer to a group of spatially dispersed sensors monitoring and recording physical conditions like temperature, sound, flood levels, and pollution levels, and sending that collected data to a central location. Now, the next wave of connectivity was to interconnect objects and people to create a smart environment. And this is the essence of IoT, Internet of Things. It is the most disruptive event since the introduction of the internet in the early 1980s. Now, there are estimates that about 25 billion, that's Gartner, or up to 50 billion, which is Cisco's estimate, things will be connected to this IoT in the next few years. So the Internet of Things, the IoT Institute defines it as a system of interconnected computing devices with unique identifiers and the ability to transfer data over the internet. The things that we are talking about could be mechanical machines, digital devices, objects, people, animals. IoT devices may be as trivial as an RFID tag on the clothing or as complex as industrial machines and robots. IoT will involve all aspects of our lives, including shopping, transportation, banking, manufacturing, healthcare. It involves in all aspects of our lives. Typical applications of IoT are as listed here. For example, smart homes. You can ask Amazon Alexa to remotely lock or unlock your front door, or turn on lights, or start the air conditioning system. Smart city refers to using IoT to improve quality of life for citizens, like smart transportation, enabling intervehicular communication, smart traffic control, smart parking, and so forth. Smart industry refers to things like companies using IoT combined with AI, artificial intelligence, to better understand their customers and improve customer experience. In the entertainment industry, there is a rapid transition from scheduled programs to audio and video on demand and live streaming, providing customers with more control over what they listen to or watch. In the healthcare area, IoT is used for sharing information between patients, doctors, hospitals, and pharmacies. Okay, we are on slide 5 now. There are some specialized IoTs. Sometimes they refer to these things. Despite the enthusiasm of potential of IoT, there are barriers to its universal adoption. So therefore, there are now some small-scale or isolated IoTs implementations, for example, like Internet of Medical Things. That is, you can soon measure, for example, your blood sugar using an app on your Apple Watch and send it to your doctor. There's also industrial Internet of Things, which refers to tight integration of computers, networks, and physical objects for the industry, for example, on a factory floor. Internet of Energy is like metering, monitoring, protection, and control of power systems to shift toward green energy. There's also actually Internet of People. This is to represent people as cyber entities considering interaction between people and devices, and providing services in a smart environment, like finding directions, for example. Finally, the Internet of Vehicles is to enable vehicles to communicate with other vehicles, people, and roadside units, and the Internet. So that is where I actually go to Internet of Things and cars. And typical cars have about 100 sensors measuring parameters like speed, fluid level, tire air pressure, and inside temperature, outside temperature. In an autonomous car, actually, let me also say something about the levels of automation, which are 5 levels of automation are defined by Society of Automotive Engineers. In an autonomous car, we have up to 1,000 sensors. And most cars right now are at level 2, where there is a driver assistance. Things are assisted drivers like cruise control, backup camera, and large yeah, for example, lane changing warning, things like that. Level 5, which is the ultimate automation, refers to fully autonomous cars, no driver involvement. In such a car, there is no steering wheel, no gas pedal or brake pedal. It's basically like a supercomputer on wheels. Now, an autonomous car, of course, first of all, must see, and then must understand, and then plan. There should be systems to do that. Devices used to see include cameras, radars, LiDARs. Radars are, of course, radio waves to determine range and velocity. LiDARs do the same, but they use pulse laser light. They could have a resolution of up to 5 centimeters at the range of 200 meters. So radars and LiDARs complement each other. For example, LiDARs is good for short distances, but it fails to detect in fog or snow. Radar is good for longer distances, can detect in fog or snow. And actually the leading LiDAR company is Mobileye, which is an Israeli company that was recently bought by Intel. Actually, about 3 years ago was bought by Intel. Now, artificial intelligence tools and algorithms with deep or unsupervised learning are needed for autonomous cars. Because there are millions of examples. Here we can use millions of examples to train an AI system. However, despite all the training, there must be edge cases which confuse the AI system, and there have been actually some accidents, fatal accidents, due to detection failure. One was Tesla not detecting a white truck crossing the road against the sunlight. That was in 2016, and the driver of the car was killed. The other one was about almost 3 years ago, Uber not detecting a pedestrian crossing the street. That was in Phoenix in the US. Okay, so one of the most famous autonomous cars is Waymo by Google. It's one of the most successful projects. By the way, Google has the largest number of patents on autonomous cars. A Waymo car uses 9 cameras, 3 lidars, I mean, 2 radars, which are one in front, one in the back. The Waymo fleet has been test driven for more than 3 million miles on US highways in the past few years, with about only 3% driver involvement on average. I have to shift between two computers here. Autonomous taxis or robo-taxis are now operating in Phoenix and Pittsburgh in the US and in Singapore. Uber self-driving cars have been operating in California since 2019. Also, there are autonomous trucks that have been operating on the German Autobahn as well as the US interstate highways between California and Arizona. They operate between the access and egress to the freeway because it's very difficult to do the local parts. Sorry. GM has developed an electric autonomous SUV for 6-passenger riding sharing. It's called Cruise Origin. And there's a website you can go see. And it's waiting for approval to operate in the urban areas. The Uber's vision is, Uber, of course, everyone's familiar with Uber. In the US, we call them the robo taxis or cars that you can hire. Uber's vision is that in the future, you don't need to own a car, actually. You just summon one when needed, and Uber will come. It has a research center in Toronto with more than 100 PhD people working on this. So in a connected car, which is an important part of the smart transportation system, where there is communication between cars and infrastructure and people. And even not being autonomous, connected cars can reduce accidents and improve air quality. There are standards actually, V2V, vehicle to vehicle, V2I, vehicle to infrastructure, and V2X, vehicle to everything that are being developed. The connected cars are being tested around the world. Japan is the leader in this area, where there are estimated 170,000 connected cars. Now, I'm going to show a little video clip here with a fully autonomous and connected car everywhere. That's not realizable. However, there will be no need for external controls like traffic lights. Now, let me see if I can bring this up for you here. Just a second. I had it here. Let's see. Now, I don't know if it's visible.
It is visible over here.
Okay, good. This is by Volkswagen. Actually.
The video is not visible.
Oh, the video is not visible. Oh, wait a second. The video is not visible. All right. So I'm sharing. How come I'm screen sharing?
Deepak sir, can we do the video from the Ekansh end?
Okay, let's see. Let's see if this works. No, does it? Video is not visible, is it?
No, it is not visible. Still, it is
so
not
you can stop sharing and then share again. Maybe then it might be visible.
Sir, you need to stop sharing this PPT and then you can share the video.
I see. Okay, just a second. Okay, just a minute. I have to stop this first. I can't get rid of it. Anyway, this didn't work very well, so sorry. What it is?
Sir, we have your PPT, so we can play this video. Wait a minute, Ikansh.
Okay. Yes, sir,
Okay.
I'm playing. Yes,
You just play the video and share the screen.
Okay.
He's playing, sir.
Okay, fine. Okay, let me know when it's done, because I can't see.
Sure.
Okay. Are we there?
Yes, he is doing, sir. Wait a minute.
Okay, good. Okay, let me know when it's done.
It's normal, sir. We all have to bear with this.
Okay. Okay, all right. Stop.
You can't stop the video.
Okay. All right. Thank you. This is an advertisement by Volkswagen because the Cedric is their autonomous car. Okay, let's get back to the screen here. So, all right. I'll be back here. Do you see can you see slide 11 now?
No, sir,
Kindly
not
share your
yet.
PPT again. You are visible, but kindly share your PPT again. Is the talk over?
No.
Then please share the PPT again, sir. Share your screen.
The screen. Yeah. Okay. We there now?
Yes, sir.
Yes, it is visible
now, sir.
Okay.
Yes, sir.
So let's talk about IoT enablers. IoT devices are expected to generate an estimated 130 exabytes of data per exabyte. I mean, EB is exabyte, which is a 10 to the 18 bytes of data per month. Now, by the way, about 50% of internet traffic is estimated to be due to YouTube and Netflix. Anyway, this powerful, we need powerful data analytic tools and algorithms to process this large amount of data. That's one of the enablers. The other is that right now IPv4 with 32-bit address provides only about 4 billion addresses, which is not enough. IPv6 with 128-bit address can provide hundreds of billions of addresses, and this will help with IoT. It's being deployed, but not universally. Only certain islands are using IPv6. The other thing is 5G wireless, which is coming around, will make more efficient use of the spectrum using AI techniques. Also, it uses better antenna technology and achieves lower latency than the LTE that we have now. It has a latency of about 10 milliseconds, which is essential for autonomous cars. Because the reaction has to be very fast, otherwise there are going to be problems. So there are limited implementations of 5G. Now, in some companies like AT&T and Verizon in the US have it. T-Mobile advertises that they have 5G all across the US, but not quite. Verizon used it actually during the February 2020 Super Bowl in the US. South Korea showcased it in their 2018 Summer Olympics. And so 5G is now built in many new smartphones. Security and privacy are primary inhibitors of adopting IoT right now. The acceptable security and privacy is one of the enablers, and right now there are issues with security. So I would like to show this website if possible. Let me share again this website. This is a website that visually shows the data breaches up to very recent times. Let me see if I can bring it up. Okay. Is that visible now?
Yes, sir. It is visible.
Yes.
Okay, good. So this is the world's biggest data breaches and hacks, and the circles has the name of the company that was breached, and the size of the circle shows the amount of breach or the severity of the breach. And you'll see that it goes up to 2020, which is very recent, and you see all these breaches, and it goes back all the way to earlier dates. So you see that even this past week, we had 4 zero-day attacks. Zero-day attacks are attacks that there's no patch or correction for them yet. So, these are coming at a fast pace, and they're becoming more and more sophisticated. You see that there are actually, they run about India here, Indian citizen. So if you click on any one of these circles, it gives you the details. Anyway, this is a very useful site. So let me go back to my slide. All right. Okay, so the other thing is that these attack tools, well, also I wanted to mention this one of these things, Equifax, that I refer to later. Anyway, it's estimated that the average cost of a cyber attack is $2 million, the average. That's including brand damage, loss of productivity, falling stock price, because when a company gets attacked, their reputation is damaged, their stock price usually falls. But their attack tools are available very freely. Some of them are actually free on the internet, available, like this thing called Shodan, which is named after a Japanese martial art character. It can search for computers with open ports and no authentication. That's the first step in an attack. That's available free on the internet. There are also more serious attack tools that can be purchased. This picture here on the right side is from Fortune magazine 2018. It is like a price list for various attack tools that you can get on the dark web. And there are many available. They can be rented, they can be purchased. One of the famous tools that is available for purchase or rent is Mirai botnet. That Mirai botnet, it has about 1.5 million zombies, zombie computers, and it rents for $60 a day. So you can unleash these zombies and create denial of service or distributed denial of service attack. This was actually used several years ago and caused problems with some prominent companies, Amazon, Google, with denial of service. Also, it was used on this little company called Dyn in the US in 2016. It did a denial of service. Dyn is the company that translated the IP address websites. Anyway, it caused a slowdown of some prominent like Amazon, Facebook, Twitter. DDoS is a tool to perform DDoS attacks, and this has actually a panel to control the zombies. And so there are attack tools, other like viruses, worms. They're getting more and more sophisticated. They can vary their behavior with time or other parameters. It is estimated that more than half of the attacks are now ransomware. Now, ransomware is where the attacker, for example, encrypts your files and then demands money, usually a few $100s, usually in Bitcoin, to give you the decryption key. So it's estimated that the cost to global organization is $20 billion by 2021, which is this year. Now, attackers can make forensics difficult. This is the anti-forensic thing. They can obfuscate for example, the IP addresses. They can delete logs and logs on the attached machines, so you can't find out what's going on. Now, hackers can go after specific targets nowadays, like a person, a company, or a country even. Also, the attacker could be a person, a company, or a nation. And an example of the nation state attacking another nation state is the Stuxnet, which was used by US's NSA against Iran in 2010. It caused some Iranian nuclear centrifuges to run faster and then damage them. So with IoT, there will be billions of attached devices, which makes security even more difficult. So let's see. Now, these are some of the sources of security problems. First of all, cybersecurity attacks can be divided into two types. One type is application-based, like phishing or denial of service or SQL injection. The other is software-based or operating system-based, like viruses, worms, or buffer overflow. Now, more recent technical development like robotics, AI, computer vision, machine learning, they are steeped in software. Therefore, software security is very important. Now, bugs may exist in software, of course, due to inadequate testing. In case of autonomous cars, for example, it's a matter of life and death. Legacy code like C or C++ with pointers or go-to statements and no rank checking are vulnerable to buffer overflow attack. Here, the attacker overflows the address field for the return of the subroutine to the main program and directs the program elsewhere to execute malware. That's a buffer overflow attack. Another source of, let me put these up. Another source of security problem is weak authentication. So many attacks are based on stolen credentials like passwords, password stealing, breaking passwords. Another source is where the users give away their information freely. For example, Western companies routinely sell their old gear to private companies in less developed countries without scrubbing the hard disk or wiping it of sensitive data. Also, people routinely give their private data like birthdays on the social media. In a new app, which is they found out to be Russian, if you put in your picture and certain other private information, the app will show how old you would change with age. So, I mean, that's an attractive app, but then to get that, you have to give freely your secret or private information. The other problem is that overwhelmed system administrators. Sysadmins are often overwhelmed with administrating too many machines, too many operating systems, dealing with variety of applications. They may neglect security patches in a timely manner. Now, a case in point that I said earlier that I would mention in that visualization chart is Equifax in the US. It's a credit reporting agency in the US. Equifax was breached in 2017, and it basically compromised billions of data items. A security patch had been available for several months, and it had not been installed. If it had been installed, that security breach would not have happened. So this is important because sysadmins have to be on top of this. The other problem is uneducated users, which are the weakest link, basically. And these may cause security problems like being a victim of phishing, downloading unsafe files. And phishing actually is one of the, okay, wait a second, before I go to phishing, let me see, no. Okay, phishing actually is one of the problems. The majority of security attacks are via email, and phishing is one of the things that is used. The bulk of phishing attacks are via email. Now, I had a actually cartoon that I don't see it in my list, somehow got deleted. Anyway, so let's go to security of IoT. Now, most IoT initiatives so far have focused on developing hardware and software to collect, to process, and transmit data, and not paying enough attention to security. Now, one of the problems is that IoT devices are very small, and they don't have, excuse me, they don't have enough processing power or memory, for example, to use encryption. The other thing is that they have to be identified. Every item connected to the IoT has to be uniquely identified. This unique identification is important. For example, hackers in 2015 recruited thousands of Sony IP camera into a DDoS botnet because they couldn't be identified. They just connected to the network. They're connected to the network, but anyway, they were made into zombies. FBI recently reported in Forbes magazine that a vulnerability of Philips smart light bulbs. These smart light bulbs are connected to the home network via the Zigbee protocol, and you can play with them from your phone and changing colors and so forth. But the FBI determined that these could be sources of IoT security attacks. So what are the solutions? One of the solutions is doping chips by manufacturers like a serial number so that every item can be identified uniquely. Public key infrastructure works very well for IoT, but to do this, each device needs a software agent for key generation. Now, for example, Amazon nowadays uses an add-on chip for devices connected to the AWS, Amazon Web Services, for that purpose. NIST, National Institute of Standards and Technology in the US, has developed a standard called P-256 based on elliptic curve cryptography, for which uses less processing power for encryption. Another solution is to aggregate small devices, for example, like those in a smart home or an autonomous car, to be controlled by a proxy device and then protect the proxy device. So these are some typical solutions for IoT security. The other is biometrics is also used for, okay, let me go to the next one. And biometrics can be used for biometrics like fingerprint, facial image can be used for authentication. So Apple and Samsung smartphones now use fingerprint to unlock the phone. Many companies use voice for authentication, like some of these financial companies, they use voice for authentication. However, the biometrics have a problem because they have about 20% false positive and false negative. And actually my fingerprint sometimes not recognized by my iPhone, and I have to try several times for that. So the biometrics should be used with other authentication methods, like password. We call it two-factor authentication. Some airlines are now experimenting with biometrics for ID, for identification, security inspection. In this case, you don't need a ticket or passport in that environment if it works properly. Korean researchers now are working on recognizing people from their bioacoustic signatures. This is very interesting. These bioacoustic signatures are sound waves that pass through the body and sensing the resulting signal. They claim 97% accuracy, but that remains to be seen. So I'm on my last slide right now, and I'm offering some good security practices. For system designers, they should use safe languages. I mentioned C or C++ that have pointers and no rent checking that causes security problems. Java, for example, if used instead of C or C++, has better security properties. They should consider security in the design process rather than an afterthought. Nowadays, what we do, we develop a system and then later say, oh, okay, how do we deal with security? Security should be incorporated into the design process during the design phase. Now, for system administrators, they should install patches in a timely manner, as I mentioned earlier. And they also should implement good security policies. An example of a good security policy is to log all access attempts, even for super users, or limit privileges based on the user's role. So that's important. The other thing is logging critical events and protecting logs. That helps that in case a security problem happens, we can go and analyze to see what happens, who came in, how did they do it, and prevent it in the future. Now, logs have to be protected because otherwise, if logs are the same system that has security issue, the attackers can change the logs, delete the logs, modify it. So logs are better if they are used on an external device or on a remote computer, so that if they cannot be attacked. The other one is backing sensitive data. And that could be done on a cloud or off-location computer. This is the best defense against ransomware. Because in ransomware, if they steal your data and they demand money to give you your data back, if you have your data already, that ransomware won't work. Now, the other is that if a security attack happens, quick response is essential. So an incident response plan is very useful. It's like a fire drill, basically. The The other thing is for users that protective security technologies and mechanisms like antivirus, intrusion detection systems, these are essential. And these technologies help. AI plays an important role in anomaly detection. So using strong password is important for strong authentication. And finally, education. Education is very important. Human error is responsible for most of the security attacks. So that's where I stop. And if there are any questions, I'd be happy to entertain.
No, so have
Thank you,
any
sir.
questions
Thank you so
as of
much.
now, but
Sure.
you can type your email ID in the chat box.
Are you asking me or asking the audience?
No, sir, I'm asking you. If people have any question, they can email you.
Oh yeah, email was on the first slide. It's MMALEK, Malek at IEEE.org.
Muskan, if you can type the same.
So can you please
Muskan,
repeat
M.
So you want to email your question? What about right now? Can you text or something? So
no, so we don't have any questions as of now, but people can email you.
Oh, okay.
Sir, I have a question.
Okay, fine.
Sir,
Yes,
I have a
go ahead.
question. So what is your take on the Internet of Drones as a future?
Oh, wow. Internet of drones. Well, that's yeah. Well, identification, first of all, is very important. Right now, the FDA, I'm sorry, the what do you call it? The organization that covers the air transport. There is a federal, anyway, they are trying to identify each drone and give them an identification number so that every drone that is in the air can be identified. And there are certain regulations, where they cannot go in certain areas, for example, near an airport. And still they're causing problems, but there are some regulations that are going to be coming into effect to regulate drones operations. Yeah.
Means we can say this is the future of research in as far as the Internet of Things is concerned. One of the variant of Internet of Things.
Yes. Yes, that's a good area. Yes. Right.
There is one more question, sir, from the audience. Do you think Python is a safe language when it comes for system design?
Well, I'm not going to comment on specific languages. I'm not a language expert. What when I was going to school, I was using Fortran and C or C++. But anyway, any one of these new languages, the main thing is that there should be a rank check where there is if there is data introduced in the process that is beyond a range, it should be identified, should prevent it, because buffer overflow is one of the techniques that's used, where the attacker can overflow a certain area of the program, and then cause the program to go elsewhere. So rank checking is important. Any program that has that and doesn't have pointers, in my opinion, is a good program language. Yeah.
Sir, one more question from the audience. Can you suggest any specific research domain inside the IoT?
Any specific domain inside? Well, security of IoT, you know, and all those things that are mentioned, security of IoT is, of course, very, very important. Data processing, data analytics, you know, how to process data in a faster, more efficient manner is important. So there's a lot of, there's a lot of work being done on various security aspects. And for data analytics, you know, the data processing and security are the main issues. Yeah.
So one last question from my side, that sometime it is said that Internet of Things is not a single area, but it is combination of several interdisciplinary areas rather than a single area. Means we cannot define the exactly the characteristics of the all means as far as the Internet of Things is concerned. Means in if it moves into various areas, its characteristics or the limitations, or what we call it as the changes, it changes as we move into various areas. Some says that it is the variant of distributed systems. I was attending a workshop where it was said that it is the variant of embedded systems. Someone means everyone is looking it from various perspectives. So what is your take on this? Thank you.
Yeah, you know, as I mentioned, IoT right now is being deployed in islands. We call them islands. It's not universal. To become universal, for example, you need universal deployment of IPv6, for example, because you need the the IP addresses for that if you're going to be universal, or you need faster communication like 5G. So whenever those things become universal, when IPv6 becomes universal, when 5G becomes universal, those are the those are the things we need to make IoT universal. But right now, of course, it's not universal because we don't have those. But there are effective usage, in effective limited usage of IoT, as I mentioned, in many areas. However, becoming universal, it's going to be several years away. Yeah.
Thank you so much, sir.
Thank you, sir. Thank you for your time, sir.
Sir, it was really a wonderful session, sir. Wonderful session. Thank you so much. Slowly you build up, and it was really very informative, sir. We are really thankful to you for joining us and taking out your precious time for the audience here and from the globe. Thank you, sir.
Thank you very much. I enjoyed it.
Thank you, sir.
I guess this is the end of the conference, is it?
Yes, sir.
So we
You made
you're
it
continuing.
very interesting, sir.
Okay. All right. Thank you.
Now I would like to invite Dr. Parul Yadav from IIT Lucknow for the closing ceremony.
Thank you, Muskan. It's my honor and privilege to convey my sincere gratitude and thanks to all the experts over here on behalf of IIT Lucknow. I would like to convey my sincere thanks to Professor John J. Hull, Professor Pierluigi Ciano, Mr. Aninda Bose, Professor Manu Malik, who delivered very knowledgeable and informative sessions and talks in the session. And I believe that this session is, participants will really find this session really meaningful, and they will be able to apply this work in their research. And this session, it will open a new dimension for their research. I'm also thankful to Professor Frontino, Professor Hassinen, Professor Castello, who delivered their invited talk in the morning sessions. And I'm also thankful for our guest of honor, Professor Manindra Agarwal, Pradam Shri, Chief Guest, Professor MP Punia. I'm really thankful to our Vice Chancellor, Professor Vinay Kumar Pathak, VC Dr. APJ Abdul Kalam Technical University, and our Pro Vice Chancellor, Professor Vineet Kansal, for his visionary leadership. I'm also thankful to our director, sir, and HOD, sir, Director IT Lucknow, Professor H.K. Paliwal, and HOD, sir, HOD CAC, Professor D.S. Yadav, sir, for their motivation and continuous support for this doctoral symposium. I'm thankful to Dr. Ashish Khanna and Dr. Deepa Gupta from Universal Innovators, who did very hard work for making this event a grand success. I'm thankful to entire UI team, Muskan, our media partners, and entire IIT team, my all colleagues of IIT who worked hard to turn this event into success. This doctoral symposium conducted in 2021, here we already know that around 400 papers we received, and around 74 papers were accepted with very low acceptance ratio. So I would like to convey my sincere congratulations and thanks to all the participants who worked hard, and I would like to convey my thanks to them also for being the part of this conference. And I believe that this conference will definitely provide you a new dimension for research. Once again, I want to convey my sincere thanks to all of you, and Muskan also, who carried this session since morning to evening, and she worked very nicely. His voice is very sweet, actually. So thank you, Muskan. And thank you, everyone, all the participants, all the organizing teams, all our eminent speakers. Your talks are really meaningful, and we are really carrying something with us. This conference is giving some outcome to us. So there are very few conferences symposium that come with some outcome. So I am convey my sincere thanks to all of you. Thank you, sir. Thank you, everyone.
Thank you, Parul ma'am, for the wonderful closing ceremony.
Thank you, Parul ma'am.
Thank you, sir. Thank you, sir.
Bye-bye.